Okay, well, good morning, everybody. Welcome to our CG School V-Ray Advanced Level 2 training. This is Longros at Neoscape Studios in Boston, and I'm looking forward to a good day of really interesting V-Ray workflow materials here with you guys. I just pulled up the syllabus so that we can take a snapshot at some of the things we're going to do over the next 2 days. And as per usual, I may decide to switch a couple of these topics around. We might mix and match. For instance, today I might, at the early onset, talk a little bit about distributed rendering and getting that set up, as well as some back burner rendering things at the beginning of class. But in general, we're going to jump into something that if you had taken the V-Ray Level 1 course, it'll be a bit of a reminder and a refresher, and that's the settings for linear and physical workflow. We'll use that as a foray into setting up a scene where we can begin to process all types of different materials and advanced shader techniques. So we're going to set up a scene that will allow us to, a test scene that will allow us to go through basically any shader and take a look at it. Then we're going to jump into some physical camera settings and talk quite a bit about what we can do with our V-Ray physical cameras, including stills and moving cameras, and then some options that we have in the V-Ray frame buffer to adjust exposure and so on. That ties directly into some depth of field topics and motion blur, and we're going to talk about how we can achieve depth of field and motion blur both in V-Ray, and there'll be some new shade map techniques that we look at there, but also how we can render it out and begin to control some of these things as a post-process as well, and probably we'll jump into After Effects to take a look at that. Some new features that V-Ray 2.0 includes. You'll notice that we've got dispersion and glare, and those will be some nice topics. We might actually hit on those a little earlier when we get into our shaders, but we'll see how that plays out. And then we've got some other advanced lighting effects, such as how we can create volume lights with the V-Ray environment fog, and starting to set up caustics and sort of understanding a little bit about how we can go and control caustics. Tomorrow, we're going to start to do some breakdowns of scenes. And what we may do is, you'll notice at the very end of tomorrow's class, we get into a little bit of 32-bit compositing. And we did some of that inside of Photoshop last time for V-Ray Level 1. In this case, what we're going to do is we'll start to take a scene. I think we're going to take a scene maybe from beginning to end, light a night scene, maybe do a little animation, and then bring it into After Effects and composite it. So that's kind of my big plan for what we're going to do tomorrow. Now, as always, with the folks that are here in Boston and the folks that are on the webinar, please feel free to ask any question that you have, V-Ray related, of course, throughout our presentation. We will generally work for about an hour to an hour and a half, and then we'll take a 10 or 15-minute break, stretch out our legs, and get a cup of coffee. So for those of you that are online, you'll notice that there's a chat window that you can use. That's probably the easiest place to submit your questions. Sometimes if you type it into the question panel, it's a little bit more difficult on this end to see. So I suggest you go ahead and just put it into the chat panel, and we'll do our best to get any of those questions answered. Beyond that, if there's anything that I go over that you'd like me to repeat any part of, feel free to say that as well. So one of the first things that I want to show you is that if I go to my screen here and I go to my advanced settings, I'm going to go to my color management tab, and you'll notice that I've got a Quadro FX 3800 for those of you that are interested in sort of the gear that we're running on. And when I click on color management, I get the device profiles that I have set up on my machine. In this particular case, we profiled right around our V-Ray level 1 class, so it's only a couple of weeks old, this profile, maybe 2 or 3 weeks old. Now, this monitor was profiled with a device called the X-Rite Color Monkey, and I'm just going to pull that up for you. So the X-Rite Color Monkey is a device here, a spectrophotometer that allows you to calibrate your monitor as well as measure values of colors, and we'll see when we get into our advanced when we get into our shaders, we're going to use it to do some color measurement. Now, there are all sorts of devices out there that you can use to calibrate your monitor. This is just one of them. But the fact is that I'm working in a controlled environment. I'm working in a monitor space that I happen to know what that is. In this case, it is set to a gamma of 2.2 and a color temperature of 6500. And so that is going to play a role in the first topic today, which is our linear/physical workflow. So let me open up Max. Now, my version of Max here is going to open up with a couple of scripts that I'm just going to shut down. We won't need those. But I am using the latest build of 3D Studio Max 2011. This is the 64-bit version of it, and that's important for some of the files that we'll be working on. I'm also working, if I open up my rendering tab here, you'll notice that I'm using V-Ray Advanced 20002. So just so that we know what versions we've got running of everything. So the first thing that we need to do inside of Max is something that I find that people often glance over, and that is we need to make sure that we're in the correct units. And the most important one is the system units, because that is going to tell us what the physical size and dimensions of our scene will be. Obviously, if you're using the metric system and you're working in millimeters or meters, that's fine as long as you understand that the values that you're going to use should be appropriate. So in this case, we're using inches for our scene, and we can choose whatever we want for our display unit scale. That's not really going to matter so much. But at least now I know what the physical dimensions of my scene are going to be accurate. The next thing is we're going to go to Preferences under the Customize tab. And we want to go to our tab that says Gamma and Lookup Table. So let's click on that. So first things first, we already know that we had calibrated our monitor, and it's standard to calibrate to a 2.2 gamma, and in this case we're enabling it. We're just saying yes, go ahead and tell Max that that's the space that we're in, and then we turned on our gamma to 2.2. Now I'm using this because I wanted to match what my monitor is set for. I'm less concerned about this gray box trying to look like it blends in with its surroundings. Then we've got a panel on the right-hand side that the materials and colors are going to affect our material editor. So let me turn these off for a second and hit OK and open up my material editor. All right, and as we notice, we can see what the values of these colors look like with that gamma turned off in our editor. And if I go back to my preferences and I turn on Affect Material Editor, and I'll also turn on, well, I'll just do Affect Material Editor, you'll see the shift in the gamma. And so this is going to represent it properly for me as I'm working in Max. The next piece of that puzzle, and since it's a V-Ray class, let's go ahead and make sure we have a V-Ray material in our slot, is we've got a color issue that we need to tend to. You'll notice that, let me close this just for a second. I'm going to turn on Affect Color Selectors, and you'll see that our gamma has shifted our color range in our color selections. What this is basically telling us is where we thought before 128 gray was consistently 50%, that's not true inside of a 2.2 gamma system. And the reason that is because the gamma applies a curvature to the coloration. And that curvature is giving us a lot more color range in the light values of our scene, and it's compressing the dark values. So that is one slight limitation of working in this way, is that when you get down to values that are very low, there's larger jumps in the percentages of what those gray values are. One reference that is pretty good is inside of the Max Help. If we just go ahead and list our gamma and lookup table preferences, you'll notice that the whole concept behind linear workflow is this right here. The reason that is because there's no curvature to this line. So the linear workflow means that the mathematics that you're going to use when you're compositing and so on in post are going to go together correctly. So 0.5 plus 0.5 is going to equal 1, not some different place on the curve here. So if we look at what Max is doing, this left-hand side gamma is a 1.8 gamma, and the right-hand side is 2.2, and that is the difference in the curvature that we're seeing in our color selectors. So what we were also noticing was that our black values are sort of compressed here, and then we get a lot more of these white values. So that is showing us exactly what was going on. And then here's just a different way of looking at it. This was our 1.0 gamma space. 128 gray fell in the middle. If you could imagine this as 2.0 or 2.2, 2.2 probably middle gray falls right there. 0.5, I'm not exactly sure what kind of monitor might show 0.5 gamma, and so if you ever forget these settings, you can walk through the rest of these help points. So that's fairly straightforward, except for we mentioned that we've got a color conundrum that we need to solve. And I'm going to minimize 3D Studio for a minute, and I'm going to open up an Excel spreadsheet. And it's probably a little too early in the morning for Excel, but we won't need to be in here too long. So this Excel spreadsheet I can make available for anybody who is interested. It's a very simple formula. It's essentially what I'm saying is it's a percentage raised to the power of whatever the gamma is. In this case, it's 2.2 multiplied by 255, which is our color from 0 to 255. And so you'll notice that I've got, if I have 5%, well, that's 0.05. And 5% in our sRGB value would have been 13. In this case, 5% is 0.4. And 0.4 is actually less than 1. So one of the limitations that I was mentioning was that if we choose a value of 1 in the black here, then what it's telling us is that that is actually in between 5 and 10%, roughly 7.5 or something. So we're not ever putting anything at pure black unless we go straight to pure black. But in all of the renderings and things that I've ever done, that limitation has never been a challenge. So let's jump to our 50% value, which is our 128 gray, decimal of 0.5, and now you'll see that the D-gamma value is actually 55. So I'll jump back to Max, and we can look at this value of 55. That now is middle gray. So when I see Max scenes that come over that have values that are way up in the high 200s and so on, I know that those values are going to need to drop down to be physically accurate. And let's talk about that. If this were going to be a white paint, and this surface was going to be a flat white wall or a piece of paper, white paint generally has, in between somewhere of a 75 to 85% reflectance in an average scenario. Well, if I go back to my Excel spreadsheet and I look at my values between 75 and 85, you'll see that those values are actually 135 to 178. And the reason this is important is if we go to Max and we type in, I just usually remember 180 as about a general rule, 175, 180. This value is going to bounce the right amount of light off of it. It's going to absorb the right amount of light, and it's going to bounce the right amount of light for that white wall and that white paint. Once this gets up into this range here, now we're talking about it's bouncing off almost all of the light that's hitting it in the 90+% range, and that's not going to be accurate. So if we were creating a white paint, and this might look a little different than your normal values that that you had set up, we might stop right around that number. Well, let's talk about what that means in these other values here. If our reflections are following suit, that means if this material is is going to reflect 50%, then that value should be 55 or 56 if you round up. And if it's only 10% reflective and we look at our Excel document, well, that value is 2. So now that object would be about 10% reflective. And we're going to walk through quite a bit of this when we build our material test scene, and we'll go through that a lot. Okay, so that's pretty straightforward so far. If we go back to our preferences and our lookup table, our gamma and lookup table tab, you'll see that we have below our materials and colors, we have how we interpret bitmap files. And this is a very important part of Max to understand how it is inputting images and outputting images. So the first thing is our input gamma. And you'll notice that I have my input gamma set to the same gamma I have here. Well, the reason that is, and I'll open up Photoshop. Assuming that you're making your textures in your monitor space as sort of JPEGs, TIFFs, Targas, PNG files, those types of images, which is pretty standard workflow for everybody. I'm just going to make a color swatch here. Well, 50% gray in Photoshop, and if oh, look at that, it's already set to 55%, but I'll make that 100. So if I fill this with 50% gray, and I use my eyedropper, you'll see in the info panel that says RGB is 128 across the board. And you'll see also just to the right of that, my 32-bit float value is telling me that it's 0.5 as well. So this middle gray in Photoshop is indeed middle gray. So we don't have to worry about our gamma corrections when we're inside of Photoshop. And what's nice about that is if I save this image and I just call it gray.jpg, and I go back to Max and I pull up my material editor and I click on Diffuse and I jump into a bitmap and I find that gray.jpg. Well, you'll see that we've got use image's own gamma, use system default gamma, and override. And let's look at what each one of these does. So the first thing I'm going to do is I'm going to leave it with what it was, and I'll open up grade.jpg, and I'll view that image. And if I right-click on it, you'll see what is happening. It says the gamma is 2.2, so it brought it in. It put the inverse gamma shift on my JPEG. And then my red, green, and blue, like I said, whether you decide to, how you decide to round influences whether you choose 55 or 56. In this case, is 56. And then you'll see the float value is 22%. So that's actually telling us that middle gray was no longer 50% in our gamma workflow. It was 22%. And that could, if you weren't working that way, that could throw things off as much as 30% just in that value. So this is correct. This is exactly what we want. And you'll notice that we didn't have to do anything to make that middle gray be correct. I'll change this to 55. We'll look at these two. They're identical. So what's happening is in the gamma and lookup table, the input gamma is putting an inverse gamma shift onto the texture map, letting it know that it needs to be manipulated for it to work. If I change this to 1 and I leave it at the default, look what happens to our color. So that that 50% gray no longer gets that shift, and it reads as 128, 128, and 50%, but that's going to be too bright for our system, and our images, therefore, are going to look washed out. So that's one key ingredient to this process. Now, if I go back to bringing this JPEG in, well, there was image's own gamma, system default. In that case, those two things were going to be the same. And then there's override. So if I wanted to override a file bringing it in, then I could do that. For instance, if I was bringing in an EXR file or an HDR file, I wouldn't want that gamma to be shifted that was already in a linearized color space, so we would leave that as an override of 1. Most cases, I don't even believe that you need to do that. I think it does it correctly by default. Okay, so the next piece of the puzzle there is looking at what that last slider does, this output gamma. And the output gamma, what we really want out of Max is we want to have an output gamma of 1, hence the linear workflow. We're doing all these things so that our output of our images are going to work with this linear workflow notion. However, the linear workflow is when you're working in a system of float images. So if you're rendering out EXR files, and that's what I'll be rendering out most of our times that we're working here over the course of the next 2 days, then yes, you want that. You want to have an output of 1 if you're rendering EXRs or HDR files. I highly recommend EXRs at 16-bit float, and we'll talk a bit more about what those file types mean. If you're rendering out JPEGs and PNG files and TIFFs, Targas, those types of images, then this output should be 2.2. And that is going to put the reverse gamma on it when you set it up. Otherwise, it's going to be too bright when you go ahead and render. Now, if I leave this at 2.2, what I have to be cautious of is that anytime I go to render something, anytime I go to render something out of this scene, if I'm going to save a JPEG TIFF Targa file, I don't have to touch this value at all. If I'm going to save out an EXR file or an HDR file, I need to turn my override on to 1. So that's a workflow preference that is up to you. And it really depends on what type of files you're generally creating. I tend to use my output gamma at 2.2 and override my EXRs to 1.0. And the reason that I do that is that in a studio environment, if you're rendering out, with most people rendering out tests and so on, they might not be rendering EXRs. When I'm rendering tests, I'm almost exclusively using non-clamped EXR files. And we'll set those up in a couple of minutes. So for the purposes of our class here, since we did say I'm going to render only EXRs, I'll leave that at 1. So before I move on from that, I just want to double check that there's no questions either here in Boston or online, because this is sort of a fundamental building block of what we're going to go through over the next 2 days. And I know that in some cases it's a new type of workflow, or it's a new a couple of settings that you might not be used to. So I just want to make sure that that everybody's okay with it. Great. Well, let's talk a little bit about a different method. And this methodology is if you were to leave your input gamma at 1.0 and control your files just like we were controlling them upon import, or controlling them upon export, well, we could go to our override and tell it to be an override of 2.2 when we brought it in, and we could do that for every single image that we decided to bring into our scene, except for EXRs and HDR files. It's a bit of a cumbersome task to try to do that, and of course you can script it. There are even some alternative options if I use system default gamma here and we put on a color correct. That color correct, we should be able to come in here, and we could change our individual gammas. Actually, this we'd have to put the inverse gamma on. So instead of 2.2, it's 0.4545 repeating, essentially 1 over 2.2. Also a bit of a cumbersome task. Okay. Now what that does is there are some values, there are some things to look out for that you'll want to not put gamma correction on, and we'll talk a little bit about those later when we bring in HDRs, but also when we're applying bump maps and so on. So that's the general preferences for Max and getting us ready to work. The next piece of the puzzle is how do we tell V-Ray to operate in this system. So if I click on my V-Ray tab here, and the thing that I want to look at most is my color mapping. And you'll see that this is the color mapping to begin with. Well, we want a linear output because we were talking about our linear workflow. So linear multiply at 1 and 1 is going to be correct. Now, what I want to do next is I want to tell Max, or I want to tell V-Ray in this instance, that I'm working in a gamma space of 2.2, but I don't want it to bake in that gamma to my final image. Because if I bake it in, it's going to be blown out. It's going to get basically a gamma applied to it twice. But for its internal calculations, I want it to know that it's in gamma space. So what I'm going to do is I'm going to change this to 2.2, and I'm going to choose Don't Affect Colors, Adaptation Only. And what that is going to control is it's going to tell V-Ray under the hood that it's in a gamma space, and it should recognize it for its calculations of GI and so on. Now, the difference between this and that is very, very subtle, and we should look at it with a couple of rendering tests when we talk about our materials, because it's only affecting those little nooks and crannies of the image and the sampling of what's happening in those spots. It can actually be a bit of a faster render to keep it at 1.0 and not change it, because it doesn't have to see as much information in some of those shadowy areas. But if you want it to be truly accurate, we'll choose Don't Affect Colors and turn the gamma of 2.0 or 2.2. Do not do it this way. If you do it this way, you will have a double gamma. And when we render out some examples, we'll kind of reiterate those pieces. What we'll also do is, we mentioned the linear workflow button in the first V-Ray class, but in this case we're going to demonstrate what it does, because what V-Ray has given us is sort of a one-click fixes-all linear workflow scenario. And we'll talk about how you can use that. Essentially, you'll use one or the other, and there's very subtle differences between the two. It happens to correct everything when you put on this linear workflow checkbox, but we'll render out some tests and show that in a minute. Okay, so let's do a little bit more about these physical colors, because I think it's an interesting topic, and it's something that more and more we're seeing in visualization for anything, and that's this ability to take in sort of real colors and measurable assets into our rendering engine. So I'm going to minimize this. And I'm going to see if I have I think I may have uninstalled the Color Monkey software from my machine here. If that's the case, we'll come back and we'll do it after a break in a few minutes. Yeah, so we'll come back to that. We can use that when we start to bring in material. So what I want to do now, assuming that there's no questions about this linear workflow thing or this physical workflow, we're going to go ahead and set up a material test scene. And the way we're going to do this is you've probably seen a bunch of material test scenes. There's a great reference online, vraymaterials.de, and people submit their materials for anything and everything V-Ray related. There's a lot of interesting shaders, and maybe we'll even open up some random ones and take a look at under the hood what they're accomplishing. But one of the nice things is they provide this little test ball, which I find to be very useful for going ahead and rendering out your shaders. But what we're going to do is we're going to take this scene and we're going to adapt it to our workflow, our linear workflow, and then we're also going to change it so that we have different scenarios of lighting, because it's fine to look at your materials in a sort of a controlled white box environment, but what we want to look at is we want to look at, well, what does that material do in the sunlight? What does it do at sunset? How does it look at night? We want to start to set up a few of these parameters for us to understand kind of the different reactions it has. So I'm going to open up a test scene here that I've got. Oops, I meant to hit materials. Okay. So I have two scenes in here. One, I put my name at the end of it to remind me that was the good one. But for the purposes of our demonstrations, I want to open up this material test, and I hope that it breaks like it did for us last night. So one of the things that it's going to tell us now that we have our gamma turned on is that there's a mismatch. The file that I'm opening up says that its gamma is enabled, or I'm sorry, the gamma is disabled on the file, and then the bitmap's input and output is 2.2, and then it's also telling you that my system gamma is enabled, but the bitmap's input and output are at 1. Well, I'm going to go ahead and keep my system's gamma because I know that's the one that I want, but I also noticed that somehow my input, I hadn't changed that back to 2.2, so we want to keep that at 2.2. So we're going to look at this scene a lot. We're going to go through a bunch of different shaders, our glass materials, our woods, our metals, and talk about the nuances of those. We're going to build some textures, some normal maps, some displacement. We're going to spend a lot of time looking at this. And there are going to be some things that we do that are going to take a bit of time to render. And so even before we jump into setting this scene up entirely for our physical workflow, I want to segue into setting up a couple of distributed rendering scenarios for ourselves. So the first thing that we're going to do is I'm going to open up my V-Ray settings, and I'm going to go to the Settings tab, and you'll see that I've got a distributed rendering dialog box here. And if of course, this checkbox activates it or deactivates it accordingly. And then I've got a settings dialog box. Well, the machines that we have in the network here that are ready to render, that have V-Ray installed on them, are my machine and a couple of servers called V-Ray 1, 2, and 3. And these are the machine names of those boxes. And all that I did, if I just remove a server here, to add a server, you click on Add Server and you type in the name, and you're all set. You can also coincidentally add if the IP address of the machine, you can type that in and add that in here as well. The issue with the IP addresses is that if you are in a dynamic IP address environment, they don't necessarily change that often, but sometimes they do, and the machine names generally don't change. But as one troubleshooting suggestion, you may have to consider the IP for whatever reason. If there's a DNS problem or something like that on your network, one troubleshooting alternative is to see if you're having problems with distributed rendering, to try to put in the IP address. If I click on Resolve Servers, it'll tell me the IP address of those machines. And that's a good habit to get into, just to make sure that you typed in the names correctly, because sometimes the syntax, in this case where it says boss.del-2-3, let's say for instance that I had put in underscores, boss_del-2-3, and it says, okay, it's going to send to that machine, and then I resolve the servers, and it doesn't know what to do with it. It gives me the question mark. So resolving the servers is just sort of a good thing to do before you go ahead and set off your images. All right. So one of the features that I like about V-Ray's later versions here is they've added two checkboxes down here. One is to restart slaves on render end, and another one is to save hosts in the scene. Well, distributed rendering requires these to know what these hosts are. And we're going to do a scenario where we set off a distributed rendering through Backburner, and we're going to let a Backburner machine handle the distributed rendering so that our machine here is not doing it. And if I can use this function to save the host scene in the file, the hosts in the scene file, that means when it sends that scene file to that machine on Backburner, it's going to use this host file to see those servers that I've asked it to see. If I don't do that, then I'm going to need to go to that machine that I'm going to set that rendering off from. In this case, let's say it's V-Ray 1. I'm going to use V-Ray 1 as the machine that I send this distributed rendering to through Backburner. Well, V-Ray 1, I would have to go into the V-Ray settings, and I would have to add all of these servers to it so that it would be able to distribute to them. But I save myself that step if I choose this when I send it off to that machine. Now, restart slaves on render end is sort of a quick reboot of the spawner. So as you're rendering stuff out to your distributed rendering, it finishes a job, and V-Ray spawner is ready to execute another scene. Occasionally, there can be a glitch or a hang-up or something something unexpected happens, and the restart slaves on render end is sort of a nice refresh of the spawner. Now, if you have this on and you're sending out multiple distributed rendering jobs pretty quickly and so on, you just have to keep in mind that it can take 20 seconds or 30 seconds for the V-Ray spawner to kick back in so that it's ready to go. Okay, so that's what we have here for our distributed rendering, and I'll hit OK. On the slave side of things, if we were going to make our machine available for distributed rendering, I'll go to Chaos Group and I'll choose Distributed Rendering, and we've got Launch V-Ray Distributed Rendering Spawner. So we have that already turned on in our machines here in the studio for the purposes of the class, but if I launch this, you'll see that I get an icon down here and it tells me that V-Ray spawner is running. And then it's also going to open up a copy of Max. And you'll see that it takes a couple of seconds for Max to load up. And then when it does, I've got a couple of scripts here that it tries to load when Max opens. You don't have to worry about that. I've got V-Ray Dummy 2011.max is opened up and it's ready for business. So now with that open, that machine is ready for me to send a distributed rendering to it and have it pick up. When it picks up a job, the DR scene file will change from V-Ray Dummy to V-Ray Server Scene, I believe, is what it changes to. So you'll know that it picked up and is working when that changes. So I'm going to exit out of this in this case because we're not going to distribute yet to my machine. If I right-click on the V-Ray spawner and I choose Exit, it'll close down that system. It'll close down spawner. So some things to know about distributed rendering. It depends on your network topology. Usually it's pretty solid. If you're sending jobs and you're canceling them quick, or you cancel it and then you send another job really fast after that, there takes a little bit of time for the spawner to adapt and reset itself. So you might get some notices of things not responding. But in this case, we're going to go ahead and use this file to distribute. I'm going to change a couple of my settings before I set it off. We'll have plenty of time where I'll walk through those settings over and over and over again, so don't worry about it too much. I am going to add a render element, in this case, called V-Ray DR Bucket. That's a new element inside of V-Ray 2.0, and it gives us the ability to track which machines render a particular bucket, so that's always good, especially when you're doing your first one and you want to diagnose some things. Okay, and so I'm rendering this to my frame buffer. I'm not even saving the file. I want to make sure that I've got a material applied. Looks like I do. So now I'm ready to render the scene. I'll just close down Photoshop because we don't need it taking up resources in the background. And so with distributed rendering checked, and when I hit render, it will send this file, the scene, out to those machines, and it will render to my machine. So here we go. It says saving the scene. You also see that it says that it's loading it into each one of these ones. So I've got 3 machines, right? I've got 9, 60, and 91. Excellent. I was hoping that this would break. So last night, as we were just testing out our distributed rendering in here, we got this result. And I distributed many other scenes, all for the last class, and occasionally something like this happens, and you scratch your head, and you wonder what could be going on. Well, one of the first things that we decided to look at was, well, maybe it's just a single bucket. Maybe it's just a single machine that's kind of breaking down. And so we'll let it finish there, and that looks like a mess. And so we go to V-Ray DR bucket. All right, well, here's all these pieces that it rendered. Well, let's go to a part of this image that looks gross. Somewhere right around there. Even this whole corner is not so good. Well, that whole corner is, well, a V-Ray 3, V-Ray 1, even my machine's rendering it. So it's not limited to a particular bucket. That was the first step. Because if it was just a particular one, well, maybe it's not, maybe it's missing a map, or maybe it's not seeing the network properly, or so on. Okay, so now we have a couple other things to deduce. This strange artifacting that you're seeing here is reminiscent of, sometimes you have an irradiance map that's loaded and it's the incorrect one, and it doesn't sort of match up with the scene. So it's conceivable that this is some kind of irradiance issue that might be happening. Well, if I go to my indirect illumination and I look at my mode, well, it says my single frame is fine. It wasn't coming from any irradiance map that had been previously saved, so that's not it. Well, let's look at the light cache. Okay, the light cache. Nope, there's no light cache that's being that it's being brought from either. Okay, well, in some instances, if it had an irradiance map that was loaded, you can maybe hit reset here and just clear the irradiance map so that it's lifted out of there, if you were just kind of deducing that this is the potential for the issue. So let's say that we think that it could be that. In this case, what I'm going to do is I'm going to choose my raw GI, my diffuse filter, and I'm even going to choose my reflections and refractions in this case. I'm going to use these elements to sort of see what I might deduce from it. And we're going to use elements quite a bit as we sort of investigate our scenes. Okay, well, one of the cool features of the V-Ray frame buffer that I can't seem to live without now is the new history tab. So if I hit this H on the bottom, I've got my V-Ray frame buffer history is enabled. And I want to take this file and I want to save it into my buffer, and I'll be able to load it anytime now so that we can compare and contrast to see if the issues are happening in the same spot. While we're here, if I click on options, we can tell it where the path is that's saving these temporary images, and then also the maximum size, the maximum disk space that we'll use up on it. Okay, so now we've got this ready to go. We saved it into our frame buffer. We cleared out our irradiance, and we're going to hit render again. So what's interesting is we're noticing that the light cache looks fine, and the light cache, of course, calculates on a single machine. So that's a strange phenomenon. Nope. Now we still have our buckets of black. And we let this render out. And now we're saying, if I save this one, and I make my first one A, and my second one B, and I'm just using set A, set B, well, that's even stranger. It's not even reproducing the same issue each time. So, well, let's go to the DR bucket. Well, it's not using the same DR bucket each time for those buckets, so maybe that's where the difference is happening. So we still haven't determined if there's maybe all of the slaves on our farm are messing up. Well, let's look at just going to look at A. And we'll go to our GI. I don't think my video card liked that too much. Yep, definitely didn't like it. That's okay. We'll show the last frame buffer. In this case, I'm just going to load It's only wanting to show me, actually let's load this one in there. Well, let's see if this fixes it. We'll clear it out and we'll render it one more time. It only takes a minute. While this is rendering, does anybody want to venture a guess as to what might be happening? If you're online, feel free to just type in the chat window what you think the answer might be. It's a good brain teaser. But these are the kind of things that we're going to be up against in our level 2 class. Is once you get into the really advanced techniques, a lot of it is troubleshooting, figuring out what went wrong. Some of the things that we're going to be doing too might take a little bit to render as well. So so here we go to raw GI. Well, that's pretty messed up. Raw reflection, that's pretty messed up too. Raw refraction, that's not so bad, but it's still messed up in a few spots. Diffuse filter, that one's not messed up at all. So there was one suggestion here that it could be the scene units, and that's a valid suggestion. The scene units probably wouldn't give it this random bucket scenario. You might get some strange physical phenomenon happening, but it shouldn't mess up the Yep, so there's a answer online about maybe you need to load from a pre-made light cache and irradiance, and we could try that. We could try to load from a light cache and irradiance, but this is also telling me that when it's rendering its new light cache and irradiance, it's still not working. So we tried to clear that out, and that wasn't happening. Well, in this particular scene, it's using an HDR file to contribute to the lighting. So one of my thought processes was, maybe it's not seeing the map for the HDR. So I'm going to go to Manage and Asset Tracking. And well, you'll see that there is one problem here, right? I'm pulling these maps from my C drive, and that shouldn't be the case. The file is in the X drive materials, so I'm going to make sure that I'm pulling it from the X drive. Great. Refresh this. Maybe save the scene so that we've got it, and render it out. Well, now we're really stumped. So there's a suggestion here that says, well, what if you don't use distributed rendering? What if you just render it on one machine? So definitely a good suggestion. It wasn't our map issue, though that it's possible that it could have been. So I'm just going to cancel it. We don't need to see it render out poorly again. Well, one option to look at is maybe this needs to be a UNC location. So instead of it pulling from the X drive, maybe those machines aren't mapped to the X drive properly. And we had walked around and checked each one of the machines and opened up the maps and double checked it. But it's possible that maybe it needs to be a UNC drive, and that's a pretty common troubleshooting test for Macs, even just in general, depending on your network topology and if drives are mapped. If they're not mapped correctly, at least the UNC, as long as those machines can see the network, will do it. So before we test it on one single machine, we'll go ahead and we'll test the UNC. This is a good time while this is rendering to point out that you'll notice that I have my sRGB lookup table turned on. And that sRGB is showing us what that file is supposed to look like when the gamma is lookup is applied. And what we're seeing with that off is the physical values of that scene that we would want for compositing. Okay, so now we're still perplexed. I'll cancel this again. So it wasn't a UNC. It wasn't our map paths. It wasn't the cleared light cache and irradiance. And one of the last steps we're going to try here is, well, let's turn off distributed and render. Before I render again, and continue to render that way. So while I'm thinking about it, when you're rendering, if you're rendering to your local machine, then low thread priority is a good checkbox. In this case, it was interfering with our audio for the recording, but that should fix it. And so this is interesting. It's an interesting phenomenon that we were able to render this fine. We were able to render this fine on the single machine, but not distributed. So, is it a network problem? We tried various different things, including going to the machines that we were distributing to, and it would render the file fine from there, but it wouldn't distribute it either. So here's the solution. And it's a solution that I suggest to you sometimes before embarking on a big render job. It's a good idea. If anything buggy happens at all, if there's something that is happening that is absolutely doesn't make any sense when you're going to render, like those black splotches we were getting, and you've kind of looked at a few things like the UNC paths and some of those simple things you can check off the list. Well, what we're going to do is I'm going to make a preset, and I'm going to save this preset, and I'm going to call it Mat Test so that I've got that. And that preset's going to save out all of my settings for these categories. And then what I'm going to do is I'm going to go to my Common tab, and I'm going to choose Assign Render, and I'm going to change my production render from V-Ray to Scanline, and I'm going to change it back. And I'm going to load my preset, load all that stuff up, make sure distributed rendering is on, and I'm going to render. Still no dice. And usually doing that will fix it. Switching back and forth from default Scanline to V-Ray. Occasionally, if I save this file, and I exit Max, so we're just kind of clearing everything out, and I'm not even going to load that preset. I'm just going to make my own V-Ray setting again. Here's our material test. Assign my render to V-Ray. Quickly walk through some fast settings. So I don't need to have my machine on that one, but Now let's give it a shot. Oh. I forgot to turn on my V-Ray frame buffer. So because I canceled that image, I want to wait a few more seconds before I get my frame buffer going again, or before I set off my render again, just to let those machines cancel out of the task. Because if you don't wait long enough, what happens to you is what just happened there. You see how it said it could not connect to those hosts? So we'll cancel one more second there. Odds are they will pick back up again, even if they won't connect at the very beginning. There we go. I didn't have my show calculation phase on for my light cache, which is why the rendering is looking different, but that was that's not affecting the final render. And now we're not getting any of our black buckets or anything like that. The rendering is a bit different in this case, partially because, and I want to talk about the pitfalls of what we just did. When you save out your image, if you get this random crazy stuff that's happening, there's some different random stuff that's happening in here, but that's a product of the GI and the light in this scene. You'll notice that it's not looking like it did before. Well, the way that scene was rendering prior to this is in the environment channels and the reflection channel, there was 2 HDRs loaded in there. So that's explaining what the difference was. We would have to put those back in there. When we cleared out our V-Ray settings, it cleared out all of that stuff. So when we switched it back to default scan line, it got rid of everything that was set into V-Ray and flushed it out. But I'd saved a preset thinking that we would be able to utilize that preset, and that was this matte test preset, and load it in here. And you'll see that when I brought that back, it brought these pieces in. And let's just try one more thing. And we're going to confirm a suspicion that I have. So now we're back to this thing is looking gross again. And the reason is that there's something in the way that when it saves those render preset that wasn't working, it has sort of a corrupted piece in there. So if you want to try to save your render preset and load it back up, that's not going to help you. What you want to do is you want to shift back to default scanline and build your render setting up from scratch again so that it clears out any of the ghosts in the machine. I'd saved a adjusted one yesterday. I guess in this case I forgot to bring back the light map and that, but the moral of the story there is if you get anything that's strange that's happening in V-Ray, reset back to default scanline, reset up your render settings, and it'll clear out the ghosts. Okay, so let's do this. Let's take a 15-minute break, and we'll come back at let's come back right before 9:40, and we'll start working on setting up our material scene. Okay, so we're about to come back from break, and you'll see that I'm installing the ColorMonkey design software in the background. We're going to use that in a little bit once I have an opportunity to restart my computer. I don't want to do that right now in the middle of the webinar here, but actually, just as a quick test, I'm going to see if it'll work. Okay, so it looks like that that might actually work without restarting. Well, where we had left off, we were talking a bit about exercising some demons in a file. And I was letting you know that occasionally it comes down to the point of switching to default scanline and back, and that will exercise some demons. In this particular case, I think I led you astray. And when I went to set up the file to render again, I realized what the issue was. So this is the latest render that I had done using the parameters of that scene. And I'm going to go ahead and save this one and open up my last one. It's still a worthwhile exercise because in that same discovery process, oops, get to this one. When we went to manage and we looked at asset tracking, and I refreshed it, take a look at what's happening here. This is all the shaders that are involved in this scene. When I go to my render setup, this one had those images taken out, but I had created a library, so we could just quickly pull them from a library. So I'll pull these in from the temporary library. These were the maps that were in my scene providing the lighting and so on. So I'll instance these into my browser or into my material editor. And when I go into the HDR, notice what's happening. It's pulling up a totally different bitmap path here. When I go to my asset tracker, what had happened was when we refreshed it, for some reason the refresh wasn't pulling this in. and we weren't getting these HDR files to point to the right direction. And what I noticed was that as soon as I put it into the correct spot and remap these, make sure those are applied. There we go. I think the other one is being referenced from maybe up here, and that's, we can clear that out. Yep. Save this file. Okay, hopefully that fixes the screen refresh problem there. Essentially what I had done was just gone into these HDR files and set them up so that they went to the X drive and the materials where they were supposed to come from. And for whatever reason, when we were updating the paths, they weren't. So now, with distributed rendering on, we should be able to render that out. I must have turned off my frame buffer. Since I canceled the distributed rendering, we'll wait about 30 seconds or so before starting it back up. I just find that's a good practice. Well, we'll see. We'll see if it picks up those machines that when it says could not connect, occasionally as it's going through, it won't connect, but most time it will, once those machines cancel out and are ready, it'll pick them back up. There we go. See how it says now they're added? And now that scene has been loaded. I'm just going to drop the exposure down on my file there. So there it was, the moment of truth, as it started to render out some of those buckets, and we're no longer getting the black buckets. So when I switched from V-Ray to default scanline, the reason it's sort of pseudo fixed it is because it got rid of those conflicting maps that we had that were not being seen properly from their paths. Looks like it's still having a problem, but I have a feeling that that's partially from it could have been a map path error still. There we go. So figured it out, And I guess it's just good to note that when you're experiencing these problems, it's nice to be able to know what the steps are to troubleshoot it, what to look for, if it's a networking issue, if it's a map path issue. If you go into the asset tracker, hit refresh a couple of times to make sure that all that stuff comes back in. And we were able to get to the bottom of what was happening. Well, excellent, because this is going to be a file that we want to continue to utilize to set up all sorts of different kinds of materials. And I'm going to exit out. And what I'm going to do is I'm going to open up my previous one. I will go ahead and save that one. Why not? Okay, so it's telling me that my system gamma is a mismatch because my output gamma is 1.0. Well, we said that's okay because we're going to render out EXR files, so no problem there. Adopt the file's gamma. Great. So to go along with our physical workflow, you'll notice that in this particular scene, there are this environment map of an HDR and reflection mix and those types of pieces. Now, that's not that these items here are wrong. They actually produce some nice effects. But when we get into reading what the values are, we've got this sort of mix of an HDR that has a multiplier of 4 and a multiplier of 3, and we've got a very specific scenario going on in this case. And what I want to do is I want to kind of build up our scene from scratch and take out the variables that I want to introduce as few variables into the equation as possible. So the first thing I'm going to do is I'm going to clear this stuff out and turn these off. And actually, here's where switching between default scanline and V-Ray will clear everything out for us. So great. Now we're a clean slate. I'm going to go to my environment. I'm going to clear that out. I'm going to go to my materials. I'm going to reset the material slots, and then I'm even going to take all of these. Well, the first thing I'm going to do is there's one major material group in this scene, and I'm going to take a look at what's on it. So right now that's got a glass on it. I'm going to create just a clay shader, and that's going to be a V-Ray material. And I'm going to change my value just to remind ourselves of what we might want. If we wanted 70% gray, we're talking about 116 to 75%. So actually the default there of 70 to 75% at 128 is not so bad. I'm going to call this clay. And I'm going to apply that to this particular object. Then if I select all my objects in that scene and I look at everything, you'll see that there are some other materials that come with this. Okay. Now, when you're troubleshooting a scene, a couple of the first things that you want to look for, or at least that I look for, are, do I have any non-V-Ray materials? Because in V-Ray, although standard materials will work, there are some things that that don't play exactly right. So try to keep everything set to a V-Ray material. I'll also look for V-Ray light materials, because V-Ray light materials are going to contribute to the illumination and the GI in our scene. And right now, we don't necessarily want that. So I'm going to go to this V-Ray light material and figure out what object that's on. So this ring object here is what that material's got that on. I'm going to apply clay to it. So there we go. We just removed one variable from that equation. Now the next thing that we're going to do, and just going to rename these quickly, is we're going to walk through what is happening here. So there is a bit of a floor grid that says it's 25% black that's coming in. And so 25% black should be, I guess, 75% white. Just to make sure that xmaterials floor.jpg, let's open it up. Here we go. Okay, so for those of you that are working in a color calibrated environment, you might notice some of these things from a color perspective, and we talk quite a bit about color management in our V-Ray Level 1 as well as our Photoshop Advanced class. And so we'd set up Photoshop to let us know if there was a profile that was coming in that didn't match ours. In this case, the embedded profile was sRGB. My working space is Adobe RGB. Those are similar with the exception that Adobe RGB has a higher gamut range of colors it can produce. In this case, I want to keep it sRGB since that's the native profile of that floor. Great. And then, so I've got my eyedropper tool, and if I hold down Shift with my window palette open, I can pull up my RGB of that. And I can also change that to 32-bit so we can see what the percentage is. And you see that it says 0.75. Well, that's exactly what we wanted it to be. We wanted it to be 75%. Great. So we know that the floor JPEG is fine, and it's reading out at 75%. And then when I right-click on it here, you'll see that the numbers and the D gamma have actually made it 0.53 and 137 instead of 192. But that's correct as well. That's what we want. One of the things that Max does by default that I don't know that I necessarily agree with is it puts a blur on all of your textures, and it defaults to a 1 pixel blur. If I open this up so we can see it maybe a little bit better, I'll quickly just change the tiling on this to 1 to 1. Let's do 5 and 5. So if I make this value 0, you'll see that it sharpened up my texture quite a bit. It won't actually go to 0, it'll only go to 0.01. But I'm not animating this scene. If we were going to kind of rotate around it and do some things where we're animating, maybe we would want a slight bit of blur to keep from the lines, keep the lines from flickering. In this case, I want to keep my texture sharp. So we're going to keep our textures in the range of maybe just the 0.1 blur. Okay. And I'll switch the tiling back to 15 so that we can see this. And it's nice to have this color range, just a very simple backplate that's going to bounce a neutral color. So the next thing that we have is we've got this inner ball, and that's that guy right there. And well, we notice that we've got a blend of, there's a V-Ray logo in one and an inner ball blend here. Well, this goes back to one of our first scenarios where we said we want to reduce the amount of variables, in which case we want to use a V-Ray blend if we're going to try to blend materials with each other instead of standard blends. But also in this particular instance, that's not necessarily giving me anything from a feedback standpoint, so I'm just going to apply clay over it. And then we have an object here that is our round base, so that's this piece here. And there's a multi-sub-object material. One has the V-Ray materials.de logo, and the other one has these squares. And what's nice about this is that the squares give us our 10, 20, 30, 40, all the way to 90% black. So let's open that up in Photoshop and just take a quick peek. We're going to use the embedded profile. And I'll go ahead and shift-click with my eyedropper, and I'll switch this to 32-bit. Well, that's great. That's right at 90%. That's what we want. If I hold down Control and let go, there we go, 80%, 70%, 60, 50, and so on. Great. So we know that that's correct. We've measured it in Photoshop. Coincidentally, a map like this is very handy to have around for when you're trying to set up percentages and you're getting used to these sort of gamma-corrected scenarios. Because we set up the gamma settings in Max to automatically put the inverse on it, anything that you bring in that's a texture, you don't have to worry about what it's doing. You could set it up the way you think about it here, and then it'll bring it into Max Fine. So great. Now, in this particular case, let's see what the material IDs are. We're going to select ID 2, so that's where material ID 2 is where our black squares are being implemented. And material ID 1 is this ring around the edge. Okay. So I'll exit out of that and go back up to Turbo Smooth. I'm just going to bring my clay into the edge material, and we might change it to something different, maybe a mirror or whatever, and then our base squares, we'll call these and so that's just going to pull that in. It's got a reflection on it right now, and it's a Fresnel reflection that's at 100%. Well, I'm going to turn off my reflections in that base material. We don't want to introduce anything unknown yet, and we will later on. So now we've got this torus ring. Again, this has a reflection. Let's put it off. This is 100% white. Now, 100% white is going to be 100% white. There is no ifs, ands, or buts about it. The interesting thing is, though, in a physical realm, there isn't 100% white, right? Unless you have some sort of luminous object, there's no 100% white reading. We even said that white paint is, maybe it gets into the 80% range. So what I'm going to do for this is I'm going to turn it into using the black squares. And I'm going to switch this over to our 20%, which is roughly in that white paint range. And we're going to crop it. And there we go. And then this piece, our other torus, same concept, except it has a different tiling on it. So we'll take what was the value, 10 and 0.4. Okay. Now let's save this out. I'm going to call this neutral. And we've taken out any of the sort of idiosyncrasies that we might find in different materials and shaders. The shape of this, I think, is going to be very, very good to look at. We might even begin to move the camera around. But one of the reasons that this is nice is that we have all of this curvature and the changing of the curvature so that we can see how shading affects it, where our GI will affect it, how it gets into the nooks and crannies. And we've also got this flat piece here with a rounded edge, which helps for a lot of architectural materials because oftentimes we're working with a sort of a flat surface. So that is a pretty good set of defaults. Now what we need to do is we need to come up with a lighting scenario. And I've got an area light here in the scene, but I'm just going to go ahead and delete that. And you'll see this is the extent of our scene. Now, one of the things that we should check is our units. So we said we're in inches. And let's understand what the physical dimension of our scene is. So we're looking at something that's pretty small here. This physical dimension is a 5-foot square of our object, and our object itself is, maybe 10 inches tall or a foot tall, sitting on a table, and so it's a relatively small object. That's okay. Our physical, properties will still work. It's just nice to know what size we're looking at. In the scene there are, I believe, 2 cameras. I'm going to right-click and select the camera. I just want to see what the base properties were. Okay. So I'm going to delete this camera and switch over to my other one. And so one of the things that we're going to need to do with our physical setup is we're going to have to understand what would be an accurate setting for a camera. And first thing that we need to do is understand how we're going to light this. Well, for a scenario that's as simple as possible, let's see, my layer tab looks like it's moved over to the other panel. And we'll bring it back. So if anybody's ever had that problem before of losing a panel when you switch over from dual monitor to single monitor, if you hit Alt space with that panel active, you can go to move and then just use your arrow keys to pull it over. I'm going to get rid of these extraneous pieces. We'll call this model. I'm going to create a layer here called light day and make it active. And then we'll come over to our command panel. We'll choose lights. We'll choose V-Ray. And then we're going to start with a V-Ray sun. In this case, I'm going to maybe bring it over from one side, but we can play around with how that's going to look. And of course, the V-Ray sun asks you, would you like to automatically put the V-Ray sky in the environment? In this case, to start, we're going to say yes. And of course, with the V-Ray sun and sky, the height of the sun is a determining factor in its overall qualities. So what that's done now is it's given us an environment that's here. And we've got just a standard sunny sky that is visible. It's affecting our diffuse and specular. It's even casting atmospheric shadows. The turbidity is set pretty low. And we're using the first sky model. But we might even look at changing our different sky models just to see what the net effect is going to be. And I can give people a sort of, a refresher on what these values are as we're messing with it. But we did cover that in our V-Ray Level 1 class. So we've got physical materials, we've got a physical light, we have a physical camera, but that camera doesn't have any settings to it yet that we know of. So one great reference is if you go to Wikipedia and you look up exposure values, there's a great little chart here that talks about exposure values and what they how they relate to the f-stop of the camera and the shutter speed of the camera. So working with any physical camera scenario, you have your f-stop, which is the aperture of the camera, and that's the size of the hole of the camera that's open. There's the shutter speed of the camera, and that's how long that shutter stays open, how long it exposes it to light. And then there's a film speed as well. And the film speed determines the ISO value, determines the sensitivity to light. Now, film speed in our digital world is a little bit of a misnomer since we don't pick up any artifacting like you would from a normal scenario of having to change your film speed. So in a film camera, the film speed was determined by the physical stock that you would use. In a digital camera, of course, you have settings where you can change the ISO sensitivity, and the higher that ISO sensitivity goes up, the more noise you introduce into your scene. In our digital realm, we don't necessarily have that. So we've got a scenario where we're not limited by those ISOs. Well, these exposure values here, listed on the side, can be looked up further down here, and you'll notice that these exposure values are for ISO of 100. So that's a determining factor in what we're using here. If we want our 3D Studio Max, our V-Ray camera, to operate that way, we want to make sure that our film speed is 100 if we're using those values. We can use different values if we'd like. We just need to adjust our camera settings properly. So let's talk a little bit about this. And these are really great values to have just a barometer in your mind as to what they might do. The typical scene in full or slightly hazy sunlight with distinct shadows. Well, that's basically what we just set up, right? We put a sun in the sky with a pretty clear sky, and we expect that would create some distinct shadows. Well, that exposure value here reads 15. Well, if we compare that to some other outdoor natural lights, we've got a clear sky background. That's 15. And so on. So now if we take 15 and we look it up in our table, well, here's exposure value of 15. We can figure out which F number we want it to translate to, and if we match up the f-stop to the shutter speed for f16 and a shutter speed of 1/125th of a second, that gives us our exposure value of 15. That's also known as the Sunny 16 rule. So for an ISO of 100 and an f-stop of 16, the exposure or the shutter speed is also 1/125 or 1/100th, whichever you choose to start. It's very close to each other. And so on a standard day like this, we would choose an f-stop of 16. We would have our exposure turned on. My white balance in this case, I am choosing to have it be a neutral white balance, but we're going to talk about what white balance is going to do. And then my shutter speed should be 125. And that is, if you read how it shows up, it means it's 1/125th of a second. So if this was 1,000, that's 1/1000th of a second. If this is 1, that's 1 second. And if this is 0.5, that's 2 seconds. That's 1/0.5. So just to understand how that works. Okay. So now we've got what we think should be a pretty good physical parameter of material and sunlight. And so now what we need to do is we need to get into our rendering settings. There was a comment online about not being able to see the whole command panel. We're just checking to make sure that. Just to confirm the question online there, are you talking about the right-hand side of the screen? It looks to me like it might actually be something that's either from the window that you have it playing in or the resolution of your monitor, because the tests here show that we're seeing the entire screen. What I can do, though, is let me grab the command panel and just shift it out, and at least then, as I'm adjusting the values here, we'll be able to see those a little better. Okay, so put this back one. Actually, as we pull this out, there's a lot of great stuff in here from a camera standpoint. And we're going to spend a little bit of time going over what all of this means, and there's some really great optical effects that you can do with the V-Ray cam. It's one of the most powerful features of V-Ray, I think. So let's talk through a quick rendering scenario for our test. Well, first things first, I'm going to do a single rendering. The area is going to be a view that we might start to limit that to a region. I'm going to keep my resolution at 480 by 600 for now. The idea is that I'm hoping that we can keep our render times pretty short, though we may decide to reduce this just a little bit if it becomes too long. And then you notice that I have atmospherics, effects, everything is basically turned off. And again, this is just going back to removing variables from the equations. We will turn on atmospherics and effects a little bit later. And then I have rendered frame window on for the frame buffer, but we don't need it because we're going to stick to the V-Ray frame buffer. And then you'll notice in my signed render we've got production 2002, and the material editor is also the same, and then an active shade is V-Ray RT. One cool thing that we're going to look at later is that you can actually put V-Ray RT as your production render, and so doing some things where you're rendering out previews and animations and stuff, you can actually use RT to generate that just by telling it how long to calculate. First thing that we're going to do inside of the V-Ray panel is enable the built-in frame buffer, and I'm going to render that to memory. In 64-bit, I find it's less of an issue when you're rendering out these files. If you're in 32-bit, then every little last ounce of RAM is delicate and needed. So depending on your file size and your scene and everything, you may find that turning this off and rendering directly to a raw image file is what you need. We're pulling the resolution from Max, though internally there is, I believe, the frame buffer is still taking up memory when it uses this scenario. So if you were to turn this off and make your frame buffer and Max something really small, in this case if I made it 48 by 60, then it's going to use less memory for the Max frame buffer in its thought process and just use V-Rays. We're not going to run into any problem in this scene, so it's not totally apparent. But again, if you were working in that 32-bit environment, that might be important. And for now, we're not going to be rendering to our files. We'll just leave that off. I'm going to turn off displacement for now until we get into displacement. Lights are going to be on, but hidden lights are off. And my default lights, just by habit, I turn the default lights off. They won't turn on once you have lights in the scene or once you have GI in the scene, but anyway, it's just a force of habit to make sure that that's not affecting us. Our reflections and refractions are on, and that's going to be important for us to see what's going on in our scenes. Maps are definitely on because we want those to show up. And then filter maps is not really necessary in this case of our stills. Filter maps is going to correspond to, let me pull up my scene materials here. When I get into maps, we've got our filtering of pyramidal, summed area, and none. Essentially, if I turn on none, or I turn this off, that's going to change that filtering to none. Now, for a still rendering like this, that's fine. That's less that it's got to think about and calculate. For an animation, filter maps should be on because that is going to save you from some flickering. Oh, great. Looks like the viewing problem got fixed. Fantastic. Okay, so now we're going to jump down to our glossy effects, we're going to have those on because we're going to jump into talking about all the different types of glossy. We mentioned in the V-Ray Level 1 class that the secondary raise bias is a good alternative quick fix if you have a model that has some coplanar faces to it, and if it renders some strangeness. If you just change the secondary ray bias, it offsets those pieces ever so slightly, and can help you troubleshoot some coplanar face issues. Of course, the best way to do it is to get rid of the coplanar faces, but sometimes in a pinch. And then we are going to use the 3ds Max Photometric Scale. It's not going to use Legacy Sun Sky camera model. Now, for a scene like this with a clay render and no glossies and not a whole lot of area lights and stuff, the adaptive subdivision sampler would probably do a pretty good job and be fast. But for almost everything that we're going to talk about from here on out, we're going to be pushing the QMC or the DMC sampler to do a lot of work for us, and that includes our depth of field, our motion blur, our glossy reflections, our glossy refractions. And so we're going to choose our adaptive DMC for our image sampler so that we'll get that to do a little better job. Our anti-aliasing filter, I'm actually going to turn off for the purposes of our still images. The anti-aliasing filters are going to either blur or sharpen or a combination of the two our image, and I don't need the blurring or sharpening to happen. If I was rendering out an animation, then yes, I would look at maybe a quadratic or cubic anti-aliasing filter. Of course, the anti-aliasing filter does take a little bit of resource to calculate and a slight bit of time, but it's usually not too terrible unless you do something that's a more intense type of calculation. For architectural visualization renders, I see the use of Catmull ROM quite a bit. And you'll notice that Catmull ROM puts a 25 pixel filter, so it kind of enhances the edges and the sharpness of those edges. I personally prefer not to do that, and as a matter of fact, sometimes I'll blur my image further instead of sharpening it, especially once you start to introduce some camera effects and those types of photographic results. So we're going to leave that off, and then we're going to jump into our DMC sampler. Minimum subs is 1, max is 4. That's going to be fine. In this case, the DMC sampler threshold, when that's checked, it's using this threshold right here. This noise threshold is controlling both of those values. But what we're going to do is we're going to set these so that we can change them independently of one another. So now this is only going to control the color threshold for the anti-aliasing, and this one is going to control the threshold for the noise. We talked about our color mapping settings, linear multiply. Change this to 2.2, and don't affect colors. We will talk a bit about the different types of color mapping. Again, this is the linear workflow technique. Once you start to introduce exponential and HSV and some of these other types of mappings, what you're doing is you're putting a tone map on your image, and that is going to take away that linear curve that we were looking at, that linear line that allows you to composite the way that the math should add up. So that's why we're leaving this at linear 1, 1. We'll talk about some of these very special types of cameras as we get a little further into it. Our GI environment overrides, that's going to be off, but it might be worth just mentioning a couple of things we can do there. Indirect illumination. Well, to start out, the very, very first rendering that we do, I may just leave indirect illumination off, and just to double check, and then we'll come back and turn that on. And then we'll also talk about getting caustics turned on as well once we want to see some of those effects. Our defaults are going to be fine for right now in terms of DMC Sampler. I am going to change my render region subdivision to be a little bit smaller. I find that when you're working in distributed rendering, a little smaller bucket size helps the files pick up a little faster. And of course, we want distributed turned on. We want to make sure that these boxes are all set, so that's good. And then in the V-Ray log, it might be worthwhile as we're first troubleshooting to change the level up to 4 and see what additional information V-Ray is going to tell us about what's happening under the hood. So with that said, anytime we do a rendering, and this was a common theme inside of our level 1 class, is we are going to use the render elements. I liken it to a doctor taking an MRI or an X-ray. All this additional data that you can essentially get for free to figure out what's going on in your scene. So as we're going through our shader tests and we want to see what the contribution of the reflection versus the refraction and any of those elements. So we're going to choose V-Ray Diffuse Filter. I'm going to choose, let's grab the raw GI, the raw lighting, raw reflection, raw refraction, the filter. Actually, I'll grab the reflection and refraction and the regular GI and the regular lighting as well. And we're going to talk quite a bit about what all that does. Might as well choose, our distributed rendering is working fine, so we probably don't need that. Let's call that enough for now. So now every time we render our scene, it's going to drop all these elements into our frame buffer and give us an opportunity to look at it. One important thing about our color mapping is that our clamp output is off. As soon as you clamp your output, you no longer get your float values, and we want to keep those values that are going to be higher than 1 or potentially higher than 1. So with all that set, without GI, we'll do 1 rendering. All right. I think all right. So now, whoops, here's our render, and we need to make sure that sRGB is on. So this is giving us the correct look of the scene that we're after. This is what the information is under the hood. Okay. That's all working the way it's supposed to. Now let's get our GI turned on. I'm going to stick with a radiance map and light cache for this. And I'm going to change this to custom for now and make my max and min rates a bit larger so that it doesn't take as long to calculate. And we'll look specifically at the GI to see what it's doing. A personal preference that I have is I just tend to turn off multipass so that instead of it traveling around the scene 3 or 4 times, individually for passes, as it reaches a bucket, it finishes that entire bucket. It will end up with the same solution. And then our light cache, I'm going to reduce that to 500 for tests, but it might be worth going over a little bit of what we've done in V-Ray 1, where we just very quickly turned off all of our filtering and our interpolation, and we saw what each one of the light cache and irradiance was doing. But let's just start with this, and I'm going to show the calculation phase. Excellent. So now our clay shader is working the way that we would think it would. We're getting sort of this blue in the shadow. You could see the overall illumination of the GI, what that's contributed. So here's our diffuse color. That's the textures and the colors without any illumination. Here's what our GI is looking like, and of course that's very blue because of our skylight contribution. Here's our lighting, which is got a slight bit of warmth to it from our sunlight. And here's the raw global illumination, and the difference between the raw global illumination and the regular global illumination is that the raw GI gets multiplied by the diffuse filter to develop that pass. So those two elements get multiplied together to create this one. And that's a common scenario for all the raw passes. So if we look at raw lighting, that's the raw contribution of that sunlight. And once the raw lighting gets multiplied by the diffuse, we get this lighting pass. Raw reflection, of course, there's no reflection on this object. There's also no refraction yet. And then no self-illumination and no specularity. Okay. So in our scenario here, I'm just going to shrink this down a little bit. What we're able to do, and a few things that we're going to use often, we're going to turn on this eye for show pixel information, and that is going to give us a readout of the colors of our file. And if we right-click anywhere on there, we can look at what that readout is. If we're going to make some corrections to our scene by virtue of adjusting exposures and levels and curves inside of the V-Ray frame buffer, for instance, this scene in a clay render is underexposed. Now, if I turn on my exposure, and exposure is on here, my correction control is open, and I can start to lift this up. If I pull this up exactly +1, I've raised my camera exposure up 1 stop. And 1 stop corresponds to either a change in the f-stop of the number. So for instance, what I had just done is I went from an f-stop of 16 to an f-stop of 11. That's 1 stop difference. Alternatively, if I stayed at an f-stop of 16, which was 125th, and I wanted that to be brighter, we would leave our shutter open longer. And so instead of it being 1/125th of a second, it would be 1/60th of a second. And you'll notice that that's generally, as these work, that is this number are divided by 2. So to go, the difference between 1/60th of a second goes to 1/30th, to 1/15th, to 1/8, to a quarter. Each time you double the amount of shutter speed, you raise it a stop. Now, in our particular case, it doesn't necessarily matter what I'm changing. If I'm changing the shutter speed or the aperture, because I don't have depth of field effects on. So we're not introducing any of those optical changes that would be occurring. However, when we get into talking about depth of field and talking about motion blur, our f-stop and our shutter speed are going to be very important and have a huge amount of control over what our final scene looks like. So there's a question, if you want to increase one stop, you reduce the shutter speed according to the table. It's a, essentially, instead of the camera being open for in this case, 1/125th of a second, it's going to be open 1/60th of a second, and that's one stop. If we wanted to go 2 stops, if I made this value go to 2, well, that's 1/30th of a second. And just to prove a point here, notice what this looks like. I'll go to my history and I'll save this. And I'm going to have all these windows open, select my camera, and I'm going to change my shutter speed to 30, so 1/30th of a second, and I'm going to render it. And so you'll notice that that looks exactly like this image when we went up 2 stops. So they're identical results. Okay, so what we discovered in this particular scene, I'm going to drag this back down to 0. Actually, yeah. Okay. What we had discovered in this scene was that a 60th of a second was going to be about right. A 60th of a second, what we're looking for in the scene, and notice what I'm doing here. I'm sort of right-clicking and I'm looking at the numbers of the pixel information. Well, if I drag it over the brightest areas, you'll see that that value is getting to about 0.89, 0.884. It's getting close to white, and that makes sense because we're taking our lighting values, our raw lighting. So these values are raw lighting. You see how the sunlight pass is reading out hotter than 1. That's 1.2. Those values are above 1, and it's probably above 1 over here, 1.3. So the sunlight is brighter than white, right? We expect that. We would expect that to happen because it's such an intense light. But by the time that gets multiplied against the material color, and that's how much light that object absorbs or reflects, then once it gets multiplied by our color here, we get this result. And it's actually the sunlight gets multiplied by the diffuse, and that gets added to the GI, the raw GI that's multiplied by the diffuse. And we're going to set up in V-Ray Advanced Level 1, we sort of did this in Photoshop. We brought in all the elements and talked about the compositing math of how they go together. In this case, what we'll do is we'll open them up in After Effects and just set it up a different way so that we can see a couple of different scenarios of how to think about compositing these elements. So what you're looking for, and the reason that we're measuring these values, is this is going to help us determine our exposure. Because as you'll notice, and it's very, very important to have an unclamped situation, as I drag this higher, even if I go up half a stop from where we were, well, now if I measure these values, I'm getting values that are above 1. And values above 1 are fine in areas that have sort of a specular highlight or maybe are reflecting the sun and get these sort of hits of light. But values above 1 on a material like this obviously yields a blown out solution. It's too bright and it's overexposed. So we dialed in our exposure values specifically so that it's working with this material. One of the things that you're going to notice is, depending on the lights in the scene and depending on the materials, we may need to slightly adjust our exposures separately. Okay, so we've got a decent, easy clay rendering here, and I'm going to go ahead and close this down. You notice that we turned on all this verbiage for the V-Ray frame buffer. And you'll see what's happening sort of under the hood here. It's checking validity of the objects. It's building the tree. It's allocating its memory accordingly. Gets the light manager going. Talks about the irradiance map size. This can be nice when it comes to troubleshooting. You might see some error messages or things in here that point out issues that you might not otherwise see. In this case, we know that we're fine. There's not really going to be any errors in our rendering. So we can go back to settings and we could change that back to 3. Or if you only want, very little information, you could change that to level 1, or even 2. We'll just do that so that on the next one so you can see. Okay. So let's go back to our camera. We have an f-stop of 16. By the way, we're in a still camera, and we'll talk about what the settings are for a movie camera when we're going to animate and so on in a little bit. We've got a shutter speed of a 60th of a second and an ISO of 100, and we're using this white balance of neutral. Well, let's take a look at some different white balance techniques. Let's go to daylight. And if I bring up my last frame buffer and I go to my history, I'm just going to clear these from the channels, and then I'm going to save this one. So now we've got it in there. And let's go ahead and render the new one. Great. Now let's go ahead and save this into our frame buffer history. And you can automatically see what's changing here by the 2 different values. If I set this as A and I set this as B, Well, with our daylight balance, and that's using this slight blue tone, it's subtracting the blue out of the scenes in that white balance. So what you're getting is you're getting an overall warmer effect than you would get if it was just left at neutral, where the sky contribution plays a larger role. Let's just look at a couple of different ones in here. We'll look at D65 and D50 as well. So let's render out that. All right, and now we'll save this to our buffer. And we'll set that at A and this one as B. And you'll see that the daylight and the D65 are pretty close to each other. The D65 is a slight bit cooler than the one next to it, just ever so slightly, and it has the tiniest bit of magenta into it. But D65 is a kind of a standard for lighting, as well as D50. Now D65 is what we said we calibrated our monitor for, that 6500 Kelvin temperature. So let's change this now to D50. And so now you'll notice that D50, what that had done is it subtracted this sort of orangey yellow color. And we'll save it. And let's compare the two cooler colors. So one was daylight, one was D50. And there you can see the difference between the warm and cool. So when you're using the physical camera, this white balance has quite a bit of effect on the overall perception of your scene. What you can do is you can adjust these white balances if you'd like, and render it directly the way you want it to. You can also control the color temperature separately, and let's try temperature of 6500 Kelvin. And we'll save this one. And we'll set that at A, and this other one as B. And you'll notice that our D65 and our 6500 Kelvin are identical, which is what we thought it would be, right? We knew that that was going to be the case, but just to make sure that we're following the scenario. And so if you had a very strange scene, you could start to really push these colors. For instance, if we change this to 2000 Kelvin, well, now we're subtracting all the orange out of that scene, and we're giving it this sort of really blue kind of nighttime quality. And this all corresponds exactly to the way that you would set up white balance in your camera. So let's go back to our neutral, and if we leave this as white, what we get is, I'll just render it again since it's so fast. We get something that has the appearance of, it's pretty normal. There's a little bit of if you look at the color channels here, if I just right-click, well, it's got the least amount of red, it's got the next amount of green, and then it's got the next amount of blue. So that would make sense why it has this little bit of a slight blue-green tint. And we can just read that by looking at our color values. We know exactly what that looks like. Well, if we wanted to white balance this thing entirely, what we would do is we would want these values, if this was totally 25% black and we wanted to white balance it so that white was white, we'd have to come up with a color that would subtract that out of there. You can also do this in post. So if I save this image, and in this case, actually I want to make sure, I think I have my preferences we set up to be, oh, this is 2.2, okay. So if that's the case, then I'll use System Default Gamma. I'll go to my desktop and I'll type in white balance. We'll call this a JPEG. I'll go to Photoshop. Now we can do a couple of things. We can just open it up inside of Photoshop. In this case, I am going to assign it my working RGB since it's the correct monitor adjustment. And if I go into my adjustment panels and I put on a curves, what I can do is if I put on an auto curves, it's going to try to take the colors and neutralize them. If I take this off, and if I hit Control-Shift-B for an auto color, you'll see that it's tried to neutralize the color tones. Open up this info panel. And then you can see that there's still, it's not quite 100% gray there. It's still got a slight bit more blue in it, which is what we would expect from the sky. But it does look a bit whiter than when it started out, right? So that's adjusting the white balance here. If we wanted to do this, so let me test something here. I want to see if just wanted to quickly see if there's a white balance tool in there. If I do Open As, and I choose Camera Raw, and I open up my JPEG in Camera Raw, oh, I think it was because it was already open. There we go. Now I've got my dialog box inside of Camera Raw, and if I go to my white balance tool and I grab something that I know is supposed to be white, look what it does. I know that this is supposed to be a gray tone. It adjusts my temperature for me, and I've got some control over my white balance in post. And of course, you don't necessarily need to make white white. It's up to you what you want. If you like this cool tone or this warmer tone, maybe that's what you're going for. That's completely an artistic decision. That's up to you. One of the things, though, that I would suggest is, and it's an often overlooked nuance of the scene, is that if we have a whole pile of textures that we're going to use inside of our rendering, and those textures came from everywhere. We've got some stone, we've got some brick, we've got some grass and some green leaves and so on. If each one of those textures has a different white balance to them, if they have a different color temperature, if one is warmer and one is cooler and one's got a little bit more magenta, they tend to clash when you put them into the rendering. They tend to actually sort of not look correct. So when we set up our materials in here, we're going to talk a little bit about making sure your textures are white balanced to the same to the same color temperature. So there was a question about what did I open in Photoshop to balance the colors, and I had just put a adjustment on the image that was an auto color image. That's one way to do it. Another way is to I'll just open that back up for you. So if I go to my adjustment panels here and I put on a curves, I've got my white balance tools inside of this. So if I want to set the gray point, I can pick it there and it adjusts the curves accordingly to what it determines as that point. I can also set my white point and my black point. And what it's going to do is it's going to force these colors inside of, it's going to force the curvature of these colors inside of Photoshop to try to make those settings. Just reset that. So you notice that if we pick this midpoint here that's super blue, it takes everything and it adds all this red to neutralize it. That's not what you want to do. I actually find that, and you can do your own way, I actually like, because I think like a photographer, I guess, is the ability to open as camera raw and use its white balance tool. Coincidentally, this is where we're going to do our texture white balancing as well. And of course, you can do some other nice things. You can deepen the shadows there a little bit. You can increase the contrast. Okay, well, let's do this. Let's take about just under a 15-minute break. Let's come back at 11:15. And we'll continue on our materials run and our camera solutions. And in the meantime, if you think of any questions, feel free to post them up online, and we'll do our best to answer them when we come back. Okay, so we're coming back from break, and we're having a good conversation here with some of the folks in the Boston studio. We're talking about different solutions for who'd been using V-Ray cameras up until this point. And beyond what we're showing now, in terms of the flexibility that we have for light balance and exposure, we're also going to get into depth of field and motion blur. But one new feature of V-Ray 2.0 that is a very nice feature to have is if I switch my camera, if I just hit P to go into perspective mode here, and I'm no longer looking through a V-Ray camera, well, at one point you wouldn't be able to get the same exposure out of your image as you could before. In this case now, what you can do is, well, if we wanted to create a standard camera also, if I hit Control-C just to create a standard camera, we can do that, but same theory applies. If I go to rendering and I go to environment, you'll see that we have exposure control listed, and exposure control now includes V-Ray exposure control. So of course we've got to set it to be active if we want to use it. And there's some nice controls too in terms of, do you want it to process your background and your environment maps? Sometimes you don't want that to happen. For instance, if you have a photograph that's in the background that you don't want it to tweak the exposure of, it'll just leave it alone. In this case, it's not going to affect our scene, but if we look at the mode and we go photographic, well, I could put my F number 16, my shutter speed 60, my ISO 100, my white balance neutral, and I can render it out. Get my frame buffer going on there. And there we go. Oh, I have my exposure turned up. So we're able to take exactly what we did before with our V-Ray camera and do it inside of a perspective view or a standard camera. But there's also a few more controls that are sort of nice. We could choose from V-Ray camera. And in this case, if I choose my camera node and I just hit H to pull up my camera and I double click on it, now it takes all of these settings from my V-Ray camera and it applies it to our render. So, nice feature to have. The last one is going to relate exactly to what we were looking at before from our exposure value parameter. And here's the exposure value. And here's our table that we were looking at before. So if we know that our exposure value should be roughly, in this case, I think we had turned it into, we had moved it from 15 to 14. Render it out. Oh, why didn't that work? Not quite sure why that didn't render. But it should be the same exposure value. Let's see if it'll work with a camera instead of being in perspective, just to test. From exposure value parameter, that should be 14. Let me make sure that it's not a negative number. Yep, it's not. Well, I guess for some reason it's not picking up the exposure value as a way to do that. I'm not sure why, but essentially we should be able to take our values directly from the table and do that. Maybe at one of our breaks we'll see if we missed a process in there. But at any rate, if we go back to our camera, coincidentally, you shouldn't have to be in a perspective view. You could be in a user view or an elevation view, and you should still be able to render it with those exposures turned on. I'm going to go actually turn off my exposure control. Don't want that to affect our scene. And let's do a couple of quick things. We're using a clay material, so I'll select my material, pull this into my scene. That material right now doesn't have a whole lot of anything going on. It's just a straight diffuse. There's no reflection, nothing exciting. Well, let's start to get some more interesting things happening in it. So the first thing I'm going to do is I'm going to turn up my reflection values. And my reflection value, as we mentioned, small values of this are going to have an impact in our scene. So if I go back to my Excel spreadsheet and we just sort of say, hey, if this thing's 10% reflective, even a value of 2 in the sRGB will have an effect. In this case, I'm just going to go ahead and turn it on to 5. And if we double click this, you can see the sort of subtle reflection that's happening. So that's very minimal, not a whole lot of reflectivity. Let's render it. So as we expected, that's very subtle, slight amounts happening in here. Well, here's where starting to look at what's actually happening under the hood becomes important. So our raw reflection pass in this case is not 5% reflective, it's 100% reflective. And that's what V-Ray is doing under the hood, is it's calculating 100% reflectivity. And then it's taking that value and it's multiplying it by the reflection filter. And now you see when I right-click on that, well, there's my color. It's 555. And that's what we had put in there. So it's multiplying it by this very small percentage. What does that mean? Well, that means in post, if you were to render out EXR files and you wanted to adjust what that percentage value would be, we can start to play around with what those numbers could be and develop it that way. So I'm going to open up Photoshop. Now, first of all, let me save this file. And what I'm going to do is I'm going to render a raw image file, but it's going to be an EXR. So one of the nice things that they've added in V-Ray 2.0, you could have typed in .exr before 2.0 and had it saved out your multi-channel EXR. Here, now you can just choose that file. If you choose with an EXR without saving it to use 32-bit, it's going to use a 16-bit float. But that for our purposes is going to have plenty of color information for us to use. We don't need the full 32-bit float. The key, though, is that it's float, that the values are can go above 1. So let's save this to my desktop. And let me just render it again so that it'll put all that stuff to that file. Okay. Now I'm going to go to Photoshop. I'm going to open up my test. And you're going to notice that, number one, I'm using Photoshop CS5 Extended. You can use CS4 Extended, that's fine. The key difference is you need the extended version of Photoshop in order to be able to work with layers inside of an EXR, inside of a 32-bit file. Without the extended version, you are not able to stack things up and layer them. Second thing you're going to notice is just a workflow thing that I prefer, and that's I'm using a plugin by the folks at Pro EXR, and it's a great little plugin for Photoshop. It's by the guys at FNordware, I believe. So if you're interested in it, I believe it's $95. It's included in After Effects CS5. What it's going to give us is it's going to give us the ability to open up all of our channels from inside of a multi-channel EXR. So I'm going to say alpha appears on a separate layer and hit OK, and hopefully it'll come through. Sometimes that setting crashes it, so we tried it. We won't flip the box for alpha to appear on a different layer.
So without Pro EXR, you can still do the same thing, but you have to stack all your layers, put them in the right order and blending mode?
Yeah, so there's a question about if you don't have Pro EXR, can you still bring in the files? And the answer is yes. What you would do is, instead of rendering this out through that dialog box, let me just make sure this comes up. So here's all of those pieces that that we're looking at. Here's our beauty channel. Here's our specular pass. Of course, our specular and self-illumination and the refraction don't have anything in there, but our reflection filter does, so we want that. And our raw reflection does. That's what that looks like. And our raw lighting, and so on all the way down. You could just see what these passes do. So what I can now do is I can easily stack up a scenario where if I take my raw passes, well, actually I don't even need to do that. If I take my GI, my lighting, my reflection, and my refraction, and since specular and self-illumination don't have anything, I'm just going to delete those in this instance. And I take all of these normal ones and I group them together. And I put that into a composite. Well, it's pretty simple. The reflection and refraction get added on top of the base, so I continue just to linear dodge and add these. And if I check, if I check that from my RGB at the top, you'll see that that comped it back together exactly the way it should go. Great. The next one's a little bit more complicated, and we're going to do this a bit later in After Effects too, just so that we can see how these passes go together in After Effects. But we had mentioned that raw lighting, for instance, gets multiplied by the diffuse filter in order to create its pass to look like the V-Ray lighting. So let's group these. I'm going to take the diffuse filter and multiply it. And now that these two are multiplied, I'm good with that. I'm going to turn this into a smart object, my diffuse filter, and I'm going to make a copy of it. And the reason I'm doing that is that I need to multiply my raw GI by it as well. So I'll take these two together and multiply it. Now anything that I do to this smart object, you notice that it opens up in a separate little window. Anything that I do to this will update in both locations. So that's a good trick in Photoshop anytime you want to do something that needs to, in this case my refraction would get multiplied by the refraction filter, but they're both black, they're both empty because there's no refraction, so I'm going to delete that. I can also delete my refraction from down here because that's an empty channel. And this is what we really wanted to get at from this whole discussion where it started. And that's, we've got our reflection, we've got our light, oops, and we've got our GI. And I'm going to make a duplicate of my file. Careful not to merge layers. I'll delete these from there and I'll leave my one composite. And I'll delete this from here. This way that we're just sort of comparing them side by side. Well, my light pass, just like it did before, will get a dodge, and my reflection pass will get the add as well. This should be multiply. And this should be multiply. Okay. Now essentially what we've done is we've recreated our comp from one side to the other. And the whole reflection gets put on at linear dodge. These two elements get multiplied together. The lighting, raw lighting gets multiplied by the diffuse, and the raw GI gets multiplied by the diffuse. That way, we have what we need. Well, remember we said that if I just drag my raw reflection up to the top, this is 100% reflective. Great. That means that we only have one grayscale value to adjust, and that's this value right here, our raw reflection filter. Oh, you know what? Oh yeah, nope, that's fine. I needed to have it on normal. So any changes that we make to this color will adjust the multiplication that that image should have. And we can adjust that however we want. If we wanted to put, for instance, say levels on it, let me go to my info panel. Okay, so you see that I'm changing it from what it was to say 15%. And if I continue to tweak my adjustment, want this on too. I hate it when that happens. Let me switch back to my essentials so that there we go. Okay, now in my adjustments, you'll see that as I lift this value up, I am controlling the percentage of that grayscale value. Now, in a normal scenario, we would have a mask for this, right? We don't want to affect the black areas because that black area is going to affect all of the things that are around it. But that's okay just for us to get what we want to have out of it. So I'm going to take my levels down to my reflection filter, and I'm just going to use a clipping mask and apply it to this piece. Well, forget what's happening outside of here, but what we can do now is just by dragging that slider, we can figure out what that value ought to be and post how reflective we want it. So that's 100% reflective. This is, say, 30% reflective or 32% reflective. What that means is that if we wanted to go back into V-Ray and we wanted that value to bump up to that scenario, we'll go back to our Excel and we'll say that, well, that should be maybe between 18 and 25. So let's call it essentially 22. And let's call it test 2 and then render it. So a couple of questions online, good questions. Yeah, I can save a PSD file that has these sort of layer components to them so that you can have it and remember how the multiplications and all that stuff work. That's not a problem. We can save out some of our material edits here. And then the other question was, well, why would you go back into V-Ray and even bother changing it here? What if you had fixed it in post? If you'd already sort of done it in post, why would you care about going into V-Ray? Well, the thing about that is that we're using this to determine what our values should be without, kind of re-rendering a whole bunch of times. And when we want our final render to look the way we want it to look, we just type in those values and we get it to play along. I think there was one mistake that I was making inside of my measurements of the values was that when it's up here and we're measuring those values, we merge those together. It was giving me sort of a wrong reading in the final output. But the notion is we can make tweaks in post. We can leave it there if that's what we're done with it, or we can quickly, instead of rendering a bunch of times, save out our elements, throw it in a comp, adjust our transparency, our reflection, those types of things, and dial in our settings without having to, try it 100 different iterations. Okay, so I'm going to clear my frame buffer here. I'll save out a better one. I'm going to close this down. I'll save out a better one later. Now let's talk a little bit about some material properties that are important. So one of the first things that I did when we created a reflective material is I turned on this little checkerboard backlight, and that just gives us a better readout of what's actually happening. You'll notice that I don't have any glossiness to my image, and there's also no specularity because this highlight glossiness is set to 1. Now, if you want a truly physically accurate material, then your highlight glossiness will stay at 1. Specular is really just a fake, right? It's something that you introduce. If I change this to, say, 0.5, and we get that little specular highlight, or 0.8, that specularity is not a true specular. Specularity comes from the glossiness, the reflections of the bright light sources in your scene. So it's up to you. Occasionally, it's nice to have, or it's, even in some cases it can add some impact to your scene. For the materials that we're going to create, I am going to leave our highlight glossiness set to 1 so that we're working with sort of on our theme of physically accurate settings. Doesn't mean using it is wrong. I'm just leaving it out of our equation. Well, let's look at something that's really important in creating good physical materials, and that's this checkbox right here, our Fresnel reflections. If I make this 100% reflective, that means our filter, our reflection filter at its brightest is going to be 100% white. But I'm going to turn on Fresnel here, and you'll notice that Fresnel gives me this sort of fall off, where as I'm looking at the reflections perpendicularly, it's less so, and then it's more pronounced as it wraps around the edges. In this case, my index of reflection is set at 1.6, and it's locked to my index of refraction, and so those values are tied to each other in this case. So as I lift this up, it's going to make my object much more, it's going to make that Fresnel effect much less. Essentially, it's becoming more reflective, but the fall off as it approaches the edges versus the perpendicular angles is almost identical. And IORs begin to creep up if you choose to do it this way. For metals and so on, you'll have really high IOR values, or sometimes you don't even put that on. You can just use almost a straight reflection color, but we'll talk about that in a little bit. So let's go back to our 1.6, and let's render out this material and look at our elements. Oh, we can turn off our saving. So one of the things that we're doing too, we're making it a little bit more challenging on ourselves, is we're using a white object in a bright scene, and we're looking at reflectivity parameters, where objects that have so much light reflection in them, the differences in where you actually begin to see reflections are much less noticeable. So that's an important distinction to make when you're looking at your materials. The brighter the materials, these sort of reflections are going to look less noticeable. So here's our raw reflection. As we would guess, that's still 100%. If I look at my reflection filter, however, this is where it gets interesting. This is where it's pretty cool. So here's that Fresnel quality in action. So as the angles are perpendicular to the camera, it's basically less of a reflection. As it wraps around and becomes glancing, it's more reflection. And as it even gets out here to the edges, you could see that. And I zoom way in, that's almost 50%. Come down here, that's 75%. And again, I'm just right-clicking on the values of these grayscales and determining what the percentage is. So immediately, and I'll even come over here to this corner, that's a bit more of a glancing angle, that's 75%. So immediately we're going to notice that this is given a lot more interest, a lot more visual interest to our material just at the heart of it. Let's do this. I'm going to leave this reflectivity the same, but I'm going to change my diffuse color, say, to 2. So now what you're noticing is that we've got a much more interesting looking, well, what seems to be a much more interesting looking material, and that's because just by virtue of this being a very dark surface, the reflections are more noticeable and they're standing out better. But the reality is the only thing that changed in that rendering is this color here, this diffuse color. The raw reflection, well, there is some change in the raw reflection, and that's worth noting. The raw reflection is picking up that dark color, and it's reflecting it on. So the reflections of the object itself are going to change. So wherever it's reflecting that object back on itself. So that is a limitation. If you were to try to do this in post and tweak it to red or gray, you would need to massage some of these values. And this would be a good example of bring it into Photoshop, make some quick adjustments, measure it, then set it up so that it's exactly correct in V-Ray, render it out, and then these little nuances will render out perfectly. What I'm curious about is, so here's where the sun is reflecting in our scene, and that's pretty cool. We're getting it to be 1.5 in the blue channel, 1.16 in the green channel. So we're seeing that the reflection of the sun, as we would expect, is bright, and it's hotter than 1. That's another good reason not to clamp, because you wouldn't necessarily get this. You wouldn't have that available to you in compositing. It's subtle. We're not that far over 1, but it's nice to have. And then we look back at our reflection filter, and it's the same. So I'm going to open up our frame buffer history, and we'll save this to that material. Okay, so another property in essentially all materials that we're going to want to look at is we're just giving this thing a complete coat of color, and we're not sort of giving it any life in its diffuse property. So if I look at the diffuse, we're just saying, okay, that's sort of 100% uniform everywhere. Well, one nice thing to do to your diffuse map is to come in here and choose a fall off. And my fall off, I can also do either perpendicular parallel, or I can do a fall off that's Fresnel if I wanted to choose the same kind of properties as I was doing before. And I'm going to leave this for right now. I'm going to leave it black and white so that we can just see the material. I'm actually going to make this 2 in the front because that's what our grayscale value was that we used. So everywhere this material is perpendicular to the camera, it's going to read as our original material. Everywhere where it's got a glancing angle, it's going to pick up this white material. So now let's render it. Okay, so now we get a bit of a weird effect, and I'm not calling this an improvement yet because we're just doing it to illustrate what the extreme value is. But if I go back to my diffuse filter color, well, now look what happens. In my diffuse color, it's actually giving me some of the shading to the surface just by virtue of it, if it's glancing or if it's perpendicular. Now, in this case, this is probably too severe. You're not actually applying a different color to the surfaces depending on whether it's perpendicular or not to the camera. That wouldn't be happening. We only want to use it in a very subtle way to help kind of give ourselves some slight definition to the scene. If I go to my reflection filter again, you'll notice that it was pretty much identical except for this black that surrounded it, and that was because we used a Fresnel of the same value. Let's save this, and I'll make this one A and this one B, and here's the difference. So in the diffuse filter, we're giving it a bit more quality in the sort of surface shading, but too much so. We want to tone that down. And it doesn't take much to give it a little bit of life. Okay. Let's go back to my material. And in this case, my front side, if I just actually copy this, let's make this maybe 10. That might even be too much. But I'm also going to change it now just so that we can see. I'm going to change my fall off to perpendicular parallel, and we'll be able to kind of tell what the curvature change is. There we go. Now we're getting a little bit of more interesting shading. If I look at my diffuse filter, now it starts to look a lot more subtle in terms of that slight variation, and just giving it a bit more interest. That's probably even too much. And in the case of this, and again, this is a cheat, and I know we've been talking about physical accuracy since the beginning, but occasionally there's some nice subtle nuances that you can do to cheat slightly. And in this case, if you introduced just a little bit of what you think maybe that sky color contribution would be at subtle amounts, I'm going to increase it to be a little not so subtle so that we can evaluate it. what we've done essentially is we've given the slightest bit of absorption of that light to it. And if I look at my diffuse filter, it's really slight. In fact, you probably can't, I don't know if you can see it on the screen as well. If I boost up the exposure, sometimes that's helpful. I'll crank that way up so we could see the changes. So we're just giving it this little nuance of what our sky tones might be. And we're keeping it in like a 1 to 2% change range. But that's a nice feature to have inside of some of your materials to give them a little activity. Okay, so let's look at taking this material now and let's turn it into something that's a bit more metallic, so that that we understand what the difference is there. So in my Fresnel reflection, I'll keep it Fresnel, but I'm going to change my IOR up to something that's relatively high to give me the less amount of the reflection or change in reflection as it turns the corners. And the next thing that I need to do is my reflection in metals should take on the color of the diffuse. So if I copy this fall off, in this case I'm going to instance it. And I've got some of that coloration that's happening, but I'm going to lift this up. Actually, I'm just going to grab this color. We're not even going to put in a map in here. We'll leave it as for now. So now let's do this. Let's maybe a little too saturated. All we want to do is make a slightly blue metallic material and see what the changes are, what the differences become. So not sure if this is any kind of real metal that you would encounter. We can make some gold and platinum and so on later, but the idea is that when we go to our reflection filter, notice that metals start to pick up a color. They pick up the color of what the diffuse is going to be. And so that's an important distinction when we're talking about multiplying and putting all of these pieces together. If you wanted to see what your material looked like in post with a slight bit of metallic quality to it, you would give it a bit of a tint. This also happens, and one of the things that we're going to do when we come back from lunch is we're going to look at how this affects some glass materials that might start to get some coatings applied to them. So the last thing we're going to do before we jump onto a break is we're going to go into a bit of our reflection glossiness. We're going to take a look at what this does when we make this a glossy material. Now I'm going to overdo it. I'm going to exaggerate it a little bit and make this glossiness 0.8 on it so that you could see that it's going to break up and put some imperfections in our reflection. And then you'll notice that at 8 subdivisions, and we're going to talk a bit about how many subdivisions should it take. If I double the subdivisions, we're going to get a little bit better each time in terms of our quality of our image. But let's leave it at 8 to start. There we go. So now we don't have any kind of perfect reflections happening. We see this sort of blurring around these pieces. And what that's doing is if I go to my raw reflection, well, here you go. And this is another one of those times when using your channels, using your elements, is going to indicate to you what's actually happening in your scene, more so than just looking at the final material. You can't ignore the final material, but for instance, if we save this, go back to my frame buffer, and we just look at this image, and I change my subdivisions up to 32, and I render it. Well, now you can see what's actually happening to the glossy subdivisions, what that impact is just on the reflections. So you're able to understand exactly how that's affecting the final outcome, more so than you're sort of seeing here in your render. And we're going to talk a little bit about ways to fake this, and of course there's some anti-aliasing things too that come into play when your glossiness gets involved. But these are going to be important tools for evaluating all of our shaders. One question before we break for lunch here. There's a post online here. Are there sources where we can know the physical properties of materials, and how is the color monkey going to help in this case? Well, the color monkey, and we'll do that when we get back from lunch, we'll be able to measure the actual physical colors of a material without introducing any outside light source or anything like that. So we'll know that that's the actual spectral reflectance of a material. So you could put that, we'll put that on our table or monitor on a couple of other elements, and we'll know that our diffuse color is right on. One of the issues that it doesn't solve, though, is it doesn't tell us what the reflectivity of that material is. It doesn't tell us how glossy the material is going to be. And there are tools out there currently. They're pretty expensive tools in the automotive industry and so on, where they do a lot of paint measurements and things that you can get data that tells you all the different angles of reflectivity for materials. What I predict that will happen in the near future is you'll begin to see databases of those kind of materials be available for things like V-Ray, that will essentially be a library that you can pull in a file, and it'll give you a whole BRDF curve for a particular paint, for a particular metal, and you can drop it in. What you can do now, though, there are some lists of indices of refraction and reflection that you can find online, usually with a quick Google search. And maybe during break I'll see if I can recall what one of the good websites is, and we can talk about that when we come back. So let's plan on coming back at reconvening at 1 o'clock, and we'll talk to you then. Okay, so we're just going to do a quick sound check, make sure everything's running again before we get back. Good. Looks like we're getting a thumbs up. Let us know if for any reason you can't hear the sound on your end. So where we ended up is that we were looking at our V-Ray frame buffer to deduce what was going on behind the scenes with our materials, evaluating raw reflection passes, looking at the glossiness settings and so on to find out what we were getting into. And what we mentioned earlier was that we wanted to take a peek at this object called the color monkey, and it's basically a little device that allows you to measure colors, and it looks just like this. Basically, you put it down on a sample, and it will return to you what the spectral reflectance of that piece is. So while we were on break, we grabbed a whole bunch of objects in the office here, and we started to measure those with this device. And in some cases, some of the responses are a bit interesting, what's happening. For instance, the first couple of pieces that you're seeing are actually measurements of what some light gold was looking like. And what you'll notice is that's not terribly, it's not super yellow, the super yellowy gold color that we're particularly used to. Now, in this instance, the ring that we were measuring wasn't a sort of brilliant yellow gold, so it did have a bit of a silvery quality to it. But this will be interesting when we start to bring in some of these colors, and we'll apply them to our diffuse channel and see what happens. It also is going to show us that the color of the reflection is going to make a huge difference when it comes to metallic objects. So we've got a couple of slates here that are dark gray. This was from a silver ring, a silver object that we had applied it to. The deep bluish green, we took a V-Ray dongle and we measured it, so that was that's sort of the V-Ray dongle green. And then I grabbed a piece of brass and we measured some brass, and that gave us these. What needs to happen when you measure colors with the Color Monkey is if you put it down on a piece of material that is multicolored, that has several different tones and colors in it, it's only going to measure a particular spot of that. So if we were measuring wood or brick and there was a grain or a fine pattern to it, and we're going to measure wood in a minute to see what the results are, you need to make a few different measurements. This here is our white color. This is from a piece of paper that we had set down. And then we got a couple of light grays here that were from a piece of aluminum. And then a few different grays that came from a piece of stainless steel. And I think these are probably the grays that we would expect the stainless steel to read at. In the upper right, you'll see that we've got color information in this dialog box, and it tells us what the sRGB color is. And we know that that's gray because it's equal in almost all three channels except for the blue. So because the blue channel has the lowest value, that means there's the tiniest bit more yellow to that, which is why it says dark grayish green. So the yellow is giving it that green shift. And then you'll also notice that the lab colors are in there as well, which is just not something that we're going to utilize specifically, but lab, since it doesn't, it's not color space specific, there are certain instances where having that data can be to your advantage. So we're working on a surface that is a desk that's got some, I believe it's a maple here. It could, I'm not exactly sure what the veneer is. Maybe our veneer guys have a, anyway, it's a light yellow wood, and we're going to measure it in a couple of different spots. So my first click of the button here, you'll see that we've got light yellowish brown, and I'll slide it just to see if we can get, I'll put it on a darker knot of the wood. So we made several measurements here, and they're pretty consistent. Our sRGB in this case was 213, 169, 117. This one's a little bit brighter. This one's brighter yet. Same with that one. And that one's about the same. So it's sort of a nice little device. It's not, it's not totally necessary to have. It's not like if you don't have the Color Monkey, you're not able to get yield proper results. But what is cool about this is we can take all of the color chips that we like, except I'm not going to keep that light orange one. And I'm going to create a new palette. We'll call this CG School. And then if I go back to my Color Monkey, I can grab these patches and drag them into my palette. And now once that's all set, I can export this. So I'm going to export two different ways. The first initial type of export from the Color Monkey is a CXF file. And I'll go ahead and export that to our project folder that we're working in. So that's the first one. The next export I'm going to do is I'm going to change that to an Adobe Photoshop color swatch. And we'll save that. Okay, so now if I go into my colors inside of Photoshop, and we'll do this first, so it's F6 on the keyboard, and I go to swatches, I can load my swatches from that file. So if I go to load swatches and I choose the file where we have that, I've loaded it in, and what it's done is it's put all these colors in a row down here. So this was our light gold. These were our wood samples. And let's make a new image, and I'll just make a small little swatch here. Well, if I fill with this color and I create a texture map out of this, we should, if I look at my info panel here, we'll see that we've got our RGB colors. I'll switch it over, one of them over to 8-bit so we can see the readouts. Now you might notice that there might be a slight shift in the actual RGB values that Photoshop uses, but they should be pretty close to what the Color Monkey exports. If we were to make a texture map of this, we would be able to bring that into 3D Studio Max just fine and have that work out as a correct texture for us. If we were to measure these colors here, and here we see the 218, 186, 136 is our RGB values, and we were to go into Max and we were going to apply the same notion of what that color was. Just remember what those colors were. 218, 186, 136. There's our color inside of Max, and what we're missing is if we use this color, that's too bright. What we haven't done is we haven't gamma shifted our color to meet our 2.2 gamma space correctly. So if I save my texture map in here, and we'll save this as a JPEG in materials, we'll call this wood color. And I'll make a copy of that material, and we'll come into bitmap, and I'll choose wood color. There you go. So you can see that the Color Monkey is reading the color correctly. Photoshop, we're seeing it properly. When we bring it into Max, we need to gamma correct it because we're working in our linear workflow, and so we need to make sure that that's doing it appropriately. The reason that works is because we're using a texture map, and it will automatically do it for us. We had a question here. Yeah, so there was a there was a mention that there is a V-Ray color material slider here that if you use a V-Ray color and you put your values in here, you have the ability to change the gamma correction in there as well. That is one way of going about doing it. Yes, you can do that. The thing that's nice about doing a texture map is that if somebody, let's say, is running at 1.8 gamma or 1.6 or anything like that, it will automatically adjust for that system's gamma, so you sort of don't have to worry about it. But there is also a Color Monkey plugin that's been released for 3D Studio, and it was built off a script, I believe, by Pierre Felix Breton, and I'll open up the script too. But if we go into this color chip, hopefully I still have it installed. Yep, X-Rite Color Monkey plugin. And now what it's asking is for that color book file, which is the CXF file. And it loads in all of my colors here from that color book, and I can choose whichever one I want. In this case, if I choose my light orange, and I forget exactly which one we had used, but they're all pretty close to each other, that is going to bring it in exactly the way it should. And you'll see at the very bottom here, we have our sRGB values, we've got our linear RGB values, and then we have the actual measured spectral reflectance of that color, which is a pretty cool thing to see. The previous plugin for the Color Monkey was similar, but it didn't work. You didn't have to have the plugin installed. You could just open up a CXF. So if I go to Max Script and I go to Run Script, see if I still have this. So I can open up the same way, go to my X drive, grab my material, open up the CXF. I can go to my light yellowish brown, and now I can just, if I take that out and drop this in, now I've got my color in my color slot already corrected. The nice thing about this technique, the conversion using the drag and drop, is that you don't have to have a plugin installed on all of your farm machines, and you won't get any missing plugins if that occurs. So there could still be a nice use for doing it that way. So we're going to come back to some of these colors a little later on, and begin to utilize them in our material setup so we can build some of these measured pieces. What I'd like to do before that is if we go to Photoshop and we've got a wood color here that we know is correct, well, what we can do is we can take a texture map that we want and begin to make it fit. So for instance, I believe I've got some files that I'd saved over to our project folder here. And I have some texture maps from the Airway source. Which happen to be all sorts of wood veneers. And it'll take a minute or two to open this up because they are very high resolution. So for instance, let's say we wanted to use this texture. I'm just going to drag this into Photoshop. And it says, again, we've got a profile mismatch. This is great, though. It's nice to have textures that do have a profile assigned to it, so we know we're going to keep it there. All right. So now if I take my color, in this case, my color, there's a profile mismatch because of the fact that I was working in Adobe RGB as my working space. In this case, it's not going to be that different for us. Well, we can see that it's actually not too far off. If I hit Shift with my eyedropper and I mark a selection here for RGB, and I mark a couple other spots here for my RGB, that'll apply to about the lighter areas. Let's compare. In my number one, my red channel is roughly 230, but it's also about relationships. So the red channel relationship to the green to the blue, we actually hit the nail on the head there with that selection. That was a pretty lucky choice. So we're only really off in our red channel in terms of the relationship between those colors. And here we're also seeing a similar type of notion. So what we can do, we'll leave our color there. I'll put a curve adjustment on my material. And in this case, we need to bring the red values up slightly in this zone. Now, curves, you have the ability to do that in lots of different locations. What I'm going to do in this instance is I'm going to put my I'm going to use my curve adjustment with the modify the curve, and you'll notice that it puts the dot on the curve right where I keep my eyedropper. And so if I start to drag this up ever so slightly, well, we'll see that I did do one thing, that it looked like it was changing. What's strange is that it shouldn't change this color at all. But what you're noticing is that with that curve control, we were able to adjust the RGB value. Now you'll see that the RGB is actually almost identical to what those were. And you'll even notice that the color looks very, very close as well. Another thing that you can do, so that's one option, and that's the best option, is to utilize the curves. I can also take this eyedropped color and just to see what my texture would look like if I filled a solid color layer and I put it on color, I could start to see what that color would do. I could even put it on hue. If I put that on hue, it's going to start to move the hue of that color towards my yellow. But you want to be careful about that, because that's going to take the hue or the color of all of the pieces, including the dark areas and so on, and shift it. Either way, we've got a material now. We've got a wood material that seems like it would be fairly accurate to our measurement. So I'm going to shrink this down. One of the nice things about these textures is that they're so large, and you're able to render out huge expanses. But I'm going to, for what we're doing here, I'm going to shrink it down. And I'm going to go into materials. We'll call it wood ash. And there we go. So now we have that material. Well, another nice thing about these materials specifically is that they've already gone through the trouble of creating sort of a reflection map version and a bump map version. And let's bring these in to Photoshop as well. Okay, and the only thing I need to do here is I need to shrink them down. Okay. So let's shut all this stuff down, and we will come back to it later. I'll close down Bridge so that we don't have to worry about it. And let's take our new wood material and start to create our shader. So the first thing I'm going to do is I'm going to go into my diffuse color, and I'm going to grab the bitmap, and we'll choose our wood ash. And there we have it. Now, what I'm going to do is I'm not going to bring in my other two shaders, my other two bitmaps into my reflection or my glossiness or my bump or anything like that yet, because what we want to do is we want to be very specific, at least as we get going on these first few, is we want to make sure that we're measuring what it is that we're doing. So the first thing is first, select our object, apply it, turn on our material in the viewport, and then let's go ahead and hit render. So there's a question online, why would you need a reflection map on the wood? Do some areas reflect more than others? And let me turn this on to sRGB. So you notice that our colors, it looks quite a bit different when we're when we're just looking in linear space, but when we turn on sRGB, now it starts to take on the right atmosphere. Yes, the wood is going to have very fine subtleties in terms of how its veneer and so on gets applied and how it reflects. So what we're going to do is we're going to work on those subtleties. One of those ways is perhaps there's a slight bump to it. Now what you might get is in a floor material that gets a lot of wear, or might have some cracks and crevices, you'll get those sort of bumps. When you have a very nice smooth polished veneer, you'll have subtle changes, but the idea is that it doesn't quite have that many nicks and scratches and bumps. So let's look at how we can start to control that. So we're looking at our diffuse filter. That looks like our color that we remember. And then if I look at my reflection, I've got nothing. So let's start to put on a general reflection. And in this case, we can do a couple of different things, and we should compare what those things are. If I put on a full reflection and a Fresnel amount on it, remember that this is going to be determined, the reflectivity is going to be determined by the glancing angle and by this index of reflection in this case because we're only reflecting. So let's go ahead and hit render with this. So there we go. Now we're starting to get that subtle reflection that we might get, but it still doesn't quite look like it has that full veneer effect. If we go back to our raw reflection, or in this case, if we just look at our V-ray reflection, we'll see how much that is reflecting. Part of that is a byproduct of it's reflecting the smooth blue sky in our scene. And so it is not picking up a whole lot of interesting highlights and so on. What we're going to do is we're going to modify our environment to showcase a couple of different things. One, we just set this one up as kind of, we stuck our little globe outside on a sunny day and we're looking at our materials. What we want to do is we want to be able to put it in a few different environments, maybe a sunset, maybe a night, maybe an interior room. But we'll get to that in just a little bit. Now, let's begin to compare some differences here. As my index of reflection turns up, the glancing angles affect it less. So I'll open up my history here. We'll save it. So now you notice that there's quite a bit of difference in the reflectivity of this material. It feels like it has a bit more of a coat around it, a bit more of a reflection surrounding it. And that is definitely evident when we go to look at our V-ray reflection here. It's much more reflective, or our raw reflection is going to stay the same. But our reflection filter, now we can see that those Fresnel qualities have less of an impact. There's a slighter gradient between what's reflective and what's not. Okay, so maybe this is okay. This is, starting to look like it's kind of got a lacquered finish. But let's compare this with a different technique. I'm going to make a copy of my material, and I'm going to create a V-ray blend material. And I'll keep my old as a sub-material, and in my base, I'll call this wood. And in my base material, I'm actually going to think about, well, if I remove the lacquer finish from my material completely, it's going to have sort of a different quality in the way it reads. Without the lacquer, there's a bit more of a roughness to the wood, and in this case I'm going to assume that maybe it's got a bit more glossiness as well. So I'm going to make my base coat of this thing be, I don't know, let's push it up and make a couple of tests. So my highlight glossiness, remember we said we were going to uncheck that so that we didn't get the false specular. It's up to you whether or not you want it. For the purposes of our demonstrations here, we're going to remove it. And then I'm going to up my subdivisions in this case. I don't want to go too high because I want us to be able to render pretty quickly. And let's say that has more of a subtle glossiness to it, a very subtle reflection. So here's my base wood, where you can see that as it turns the corner there, there's just a slight bit of reflectivity and it's sort of rough and diffuse. And if I take a material here, a coat material, I could do it a couple of different ways. I could make it blend with, and let's go ahead and show what both would look like. I can make a wood material that has basically a pure reflection to it and our higher IOR so that it's giving us somewhat of that effect. And right now that's telling me that it's going to be 50% one way versus the other. And actually we should check that because 55 should be 50%. Oh, we just noticed that I'd accidentally instanced my material. We don't want to do that. Okay, so what we're going to have in this case is we're going to have a blend between a wood that has a subtle bit of glossiness to it, the sort of unvarnished feel, and then another one that has sort of a more varnished look. Let's go ahead and render. Actually, let's apply that material. Yeah, so there's a question online right now is could you explain the blend material and when you should use it? And that's what we'll be getting at here is I want to show you guys what you can create in terms of some advanced shaders using a blend and a sort of a layered system of rendering out your materials. A lot of people recognize that car paint, for instance, has sort of a coat to it. There's a layer that's a base coat that generally has some more glossy and spread out a slight bit of roughness to it. And then there's a coat that goes on top that has this very sheer varnish to it. Well, in actuality, many materials get that type of property. They adhere to that. As a matter of fact, wood is one of the first ones that we're going to notice that begins to have that, especially varnished wood that has a bit of, smooth coat over the top versus not. So let's take a look at this. I'm looking at my raw reflection, and what you're going to notice is that we've got this kind of blending between these two elements. And while that maybe looks a little better than it did in some of these areas, it's still not quite right. It's still not quite what we're going for. Well, in a blend material, we can decide what we want to do with it. We can say the base material takes on a certain effect depending on whatever that is. In this case, I'm just using a linear kind of blend of half and half. So it's using half one, half the other, and that's just sort of a neutral blend. And we can tell it to have a blend depending on the fall off. So if we wanted to say at a glancing angle, more perpendicular to the image, show us more of the glossy, and more parallel, show us more of the reflective. And in this case, once I put a map in this slot, this grayscale value has no effect on it. So let's look at what would happen here. So what it's saying is that if we look at my material, wherever there's a parallel spot to the camera, it's going to be sort of our glossiness. Wherever it's perpendicular to the camera, or I'm sorry, wherever it's perpendicular to the camera, we'll have the glossy version. Wherever it's parallel or glancing, we will have our coat.
Before you added the fall off as a filter, what determined which part had material A versus which one had material B? How was it determined without specifying the fall off as being a filter?
So there's a question before we added the fall off. What was determining how much it would use material A versus B? And what we had done prior to the fall off is we had just put in a grayscale value here. And so essentially that is just a percentage. And that percentage says that whatever this percent is, it'll use the, now for instance, watch, if I turn off my map, or I'll just move it into a different slot. At this point, actually at this point where it's 55, it's 50-50. Half of that material is everywhere. Now, there are some subtle differences that are happening, though, because we've got different Fresnel qualities to it. So one had an IOR of 3 and the other had an IOR of 1.4. So the Fresnel of that material might pick up a bit more reflection, but in terms of the blend, that was just 50-50. If we want to go all the way, let's say we go all the way to white. Now it's only pulling from, it's not pulling anything from our glossy version. It's only pulling from our wood here. And then if we go to black, it goes the opposite direction, which is it's only pulling from this material. And then by using a map in here for the fall off, it's determining these grayscale values of which one to use, front or side. And here we start to get a little bit more of an interesting quality to it. We've got glancing angles that are picking up a bit more of the lacquer, and then these more perpendicular angles we're not seeing very much lacquer at all, which is in some regards it's operating a bit like the way we would expect when we're looking directly at the lacquer perpendicular. We wouldn't expect to see too much, as much shininess as when you turn it on its side. But this still isn't enough. This still isn't quite what we're looking for. So one way to adjust this is we can control the fall off colors. So the more I bring up the grayscale value of my fall off here, the more it's going to show that material at the perpendicular angles, and then it's going to really switch over to it at the glancing. So let's just make this number, say, 100 so we can see what the difference is. I'll save this into the frame buffer. And now we're getting some of that lacquer finish even when we're looking directly perpendicular to it. And if I go back to my V-Ray raw reflection, you can see how that is affecting it. Or if I go to my V-Ray reflection, you could see how much is going on. So, and that was still a pretty subtle change compared to, you know, where we were. But in some regards, that's the way materials work. It can be a subtle balance between what you want to achieve. Let me save this, and I'll set this as A, and I'll set this as B. And you can see, like I said, it was very, very subtle what's happening. It's picking up more reflection right there as it's perpendicular. Well, let's make it less subtle. Let's go to where it's almost completely our lacquered wood, and then let's also bring up this reflectivity of it. Might not go up that high. So now what we're noticing is that the lacquered wood is really noticeable, and that partially is because we reduce the amount that the glossy would take place, but we also increase that reflectivity by upping the index of reflection, and now it seems like it's covered in this coat material a little bit better. Well, this is one way to go about creating this this type of shader in this material, and I'll save this just so we've got a copy of it, where you can introduce some subtle nuances, and we're being very picky with, you know, how subtle those nuances are. But another way of doing this same material is we'll get rid of our wood material there in the second one. So the first one is still our glossiness, our glossy version, and I'm going to render it just so that we can see remind ourselves what the glossy version looked like. So this is that wood without the coat that has sort of a subtle reflectivity on it. And we'll save it. And if I set this as A and this is B, we see how much that coat reflection really begins to transform the material. Well, I'm going to take my second material and I'm going to create an actual coat. So if I make a V-Ray material here that is essentially almost like a lacquer finish, well, that's going to have some similar properties to what glass might have. So it's not really going to have a diffuse color. It's a clear material. But what it is going to have is it's going to have a reflection, and it'll probably have a Fresnel reflection to it. And now you can see that it's starting to get overlaid there. And depending on what I might even do is I might turn this coat material up further. And now we just control the amount of blend for the coat. So instead of that having sort of this wood texture involved in it as well, we're basically just putting on a reflective coat. And that method is actually going to end up looking a bit more natural than the previous one, just by applying a bit of a simple coat to that object. Now what we can do is that, let's say that this had some scratches on it or something to it. Well, we can take our coat material and we can get into our maps, and maybe we put on a slight bump to what that is. Let me see if I can find a good scratch material. I might have a grunge material that could work. Some of these might work okay. I say we grab a couple of these texture maps, I'll copy them to our directory, and we'll take a look at what happens now when you layer those into your shader. Okay, so we'll get into the bump, grab a bitmap, turn on our large icons here, and let's start with this wipe bump. Well, the first thing that we're going to do is we're going to look at this, and the bump is going to be controlled by the grayscale values. So wherever it's black, it will be indented. Wherever it's white, it's going to stick up, and we can see how that works. We can also put that to our scene and start to see where those, obviously the texture mapping will make a big difference in terms of how that's going to show through. And the size of the bump will be important. But what we're going to need to do is test render it first to get that. So what's happening here is you're going to see that we've got this, basically our shellac that we put on this has a bumpy surface that has kind of these wipe marks. Probably a little too big, judging by the material there. But let's leave it too big just so that we can see the larger effect. So you're going to notice a couple of things. Well, it's pretty slight. We introduced a few little artifacts here from how it's rendering the bump map. If we zoom into this area, you can begin to see those white marks as it's crawling up the texture. Might have to adjust our exposure here just a bit so you can see it. So you see these lines introduced in it. If I go back to my raw reflection, well, here we can start to see where it's changing. So in my raw reflection, we're starting to see some of these swipes, some of these little pits and grooves and movements that could be coming from that scratch coat itself. Well, we may even want to introduce, let's make it even bigger. And let's go to our wood and give it a slight bit of bump. And that will be our wood ash bump. And we could see that it's going to have very slight imperfections in it. It's a little bit of grooves. Remember what I said about our bitmap blur? I want to make sure that these are not getting all blurred up. Coincidentally, I have a script that that will take care of all that stuff as well. Now, without the blur, we might run into some issues there on our bump being too big, but we'll find out in a minute. And this one here only needs to be maybe 3 or 5. Let's see if this will show up in the bump normals or not. And that's actually starting to look pretty good in terms of what I might be wanting to achieve in this case. If I go to my raw reflection, you'll see that we've introduced a bit of kind of bumpiness to it. It might need to be a little bit more. Yeah, the bump normals here are a little slight. But what's going to be interesting about this is with that bit of bump, I'm going to increase it. I'm actually going to turn off the glossiness in this material. And let's see if we can get away with not having any glossiness. Because in theory, what's happening is all these little small bump pieces are breaking up the reflections and already kind of giving you a bit of a glossy quality. It's still a little sharp, I guess, in a few spots, so you might not be able to totally get away with it. So that's not so bad, and we're rendering still pretty quickly. With bumps, though, you have to be careful because you are going to run into a few of these little artifacts where it's reflecting those bright sunlight spots, and it's not going to know what to do when it comes to anti-aliasing them because the sun is so bright versus a pixel that's not that bright. And if we just measure what that color is, you'll see that that color is a floating point of 136 or 132, and that's that when it's moved next to a piece that's not is going to be hard to do. Okay, so essentially what we're saying is that there's a lot of nuances that you can do in terms of coating materials with a blend material by choosing what that coat is going to be. And you can actually blend multiple materials, right? We could have, you know, maybe there's a couple of coats of varnish. You can get as complicated as you want in the thing. What I'd like to do is I'd like to switch this to I might like to find a wood that's a little darker. There we go. So let's grab this walnut. Quickly jump into Photoshop. Just size that texture down a little bit. Okay. So let's put our new wood in here. This is going to be our walnut. I will leave our glossiness on here a bit. Going to turn up the base reflectivity and the coat reflectivity. And I might even take this just a touch off of purely reflective. One of the advantages of doing it the way that we were just talking about with this sort of coat that is varnish is that it becomes really easy to make several different veneers, using the same varnish coats and so on. This maybe is a bit too much. I probably upped it slightly too much. Keep it at 3. We could even give it a slight bit of difference in the glossiness. For instance, if we wanted it to be less glossy in the edges and more glossy where maybe people have touched it, we could control that with a bit more of a grayscale value to it. Now, in this case, what I'm going to do is we're going to try to take this material and I'm going to apply a displacement to it. And I'm going to take this wipe material and I'm going to drop it into my displacement and I'm going to turn off the bump there. And I want this to be really, really slight. And we may have to come back in and adjust these values. I'm going to use 3D displacement because I want it to wrap around. One thing I want to check is I'm not sure how the UVW coordinates were made on this object, but you just want to make sure that your material's not set. It won't recognize real-world scale. So we should be good there. I'm going to save this just so that we... the V-ray displacement modifier I don't think recognizes real-world scale. It needs to, I'm pretty certain that it needs to have a explicit UVW on it for XYZ. And I'm going to go to my common parameters. I just want to make sure displacement is on. My guess is this is going to take a little bit longer to render, and we'll probably have to tweak it some. Not getting quite as much as I was hoping out of that. Let's up this value. Let's make it really, we're going to go making it noticeable just in case, just to double check that it's actually working. Well, I think we can see that it was working. It's starting to push the bounds of our model a little bit. Well, that's good. It'll be a good test to see exactly where the displacement is happening. One of the suggestions that I make is We haven't been using it so far in these examples, but we will switch over and start to do a little bit of V-Ray RT in terms of material tests. There are some nice things about how quick you can get some feedback from V-Ray RT to adjust your Fresnel properties, your bumps, your some of those qualities. One thing that V-Ray RT doesn't do is it won't work with the V-Ray displacement modifier. It will work with the displacement in the map in the material, but it doesn't. It won't work with at least not yet. So you'll notice that once we start to really displace this thing, it's got a lot more to think about, a lot more of those micro triangles to be concerned with. And while this is rendering, let me know if there's anybody here in Boston or online if there's any questions so far. One thing that I'd like to do is I'll take any suggestions for shaders that you'd like to try to see in here. I plan on showing some things like glass, and maybe we'll do a little subsurface scattering to a material that looks a bit like maybe a V-Ray dongle or something. We'll cover a few of the basics in terms of the metals and so on, but if there's a particular shader that you're interested in, put that in like a request in the chat window and we'll see what we can do. So that displacement is working. We confirmed it. It's pretty overdone. But sometimes you have to overdo it just to make sure that you're getting what you want. What is cool about doing a test like this is that you start to see what happens, and the reason why materials that have a bit of bump or displacement begin to give nicer qualities is that it really affects their Fresnel. So those Fresnel properties of all these little pieces that are being at more glancing angles, you get a lot more definition to the surfaces that have that happening in it. Yeah, so there's a question here about dark materials requiring more subdivisions to get rid of the noise in those materials, and that's a common issue for anything that's dark, not even just materials. You know, dark areas in your scene. Essentially, what happens is in those darker areas, there's less difference between the pixels that are next to each other. They're very, very small, minute changes, and those noise thresholds that we're using tell it to be, you know, less than 1%. It stops worrying about it. So if you want it to continue to subdivide it, you have to make those values be smaller than less than 1%, which can slow down your scene considerably and be somewhat annoying. Generally, even in photographs, if you look in the darkest areas, there's a bit more noise quality to it. So it can be okay to let it remain a bit noisy. If you increase the subdivision, it's going to work up until a point where the noise threshold kicks in. There are actually some techniques that that I think are interesting kind of workarounds just in general. Some folks will work at their scene. They'll get everything set up, and then they'll essentially render it out at a higher gamma. Render it out, say, at a gamma of double 2.2, maybe if it's 4.4. And it makes all the darker areas lighter, and so it can find all the differences and the nuances better. And as long as you're rendering that as sort of an EXR or whatever, you can color correct it in post and bring it down. That's one way of going about it. In general, I don't get too caught up in some of the noise that's happening in these dark areas, particularly because it is sort of photographic. It does happen in a photo. Okay, so we overdid it with our displacement here by a lot, but we can start to see some interesting nuances that are happening. What's kind of cool is if we look at this, I turned on the bump normal so that we can start to see what the displacement triangles are doing. Well, this is really giving us our feedback of what that displacement was happening. And just like everything else, we always want to be able to sort of look at the individual layers of the components so that we can evaluate it. Now, obviously, you can start to see what's happening here pretty easily, but this is quite a bit easier to read. And we're going to get into some normal mapping either before the class is over, before the day is over, depending on our time. We're going to talk about easier ways to create some of these effects without having to go through this this full displacement conundrum. So let's do this. Let's make our amount. Let's call it 0.1. And save. And in general, it's a pretty good displacement. I mean, one of the things that I might want to do with my map in this instance is let's take it and turn it. Actually, you know what? I can turn off this bump for now. I'll grab my wipe.jpg. So I want to make sure that I instance it. And I'm going to turn it 90 degrees. We'll see. I'm not sure. It might continue to still striate our image that direction, but we'll see. Make sure low thread priority is on. And hopefully this one will go a little faster than the last. Okay, so this is still it's still a product of that UVW map. That's why it's wrapping up this direction, but that's okay. And it's a little intense yet. you know, because it's still pretty noticeable. It is taking a lot less time to render because the bump effect is less pronounced. But you can start to see that by taking this little bit of scratch in the veneer, we can begin to give it an impression that there's a bit more detail and everything going on. I think the final settings for this would probably be 0.0. My guess is that it's 0.05. What I'm going to do before I decide that is just, actually I'm going to choose my region here and render just that region. That's much more subtle. Might even still be slightly too much. But I think you guys understand we would continue to, you know, massage what those values are. Remember to look at the bump normals to determine how big that displacement, what kind of effect that's happening, or what kind of effect that has. Okay, so let's save that. I'll turn off my displacement because I'm not going to use it again right now. So what we've done so far, just to recap, we started with a general wood. We decided that we were putting some fall-offs in the color tones and that, which we didn't do in this case, but we're going to as a next step. We're going to start controlling more with our maps. And then we used a V-Ray blend material with either, in this case we used a fall-off shader or a perpendicular parallel shader to determine where it was going to happen. Of course, a V-Ray blend material, you can use any kind of map that you want. In this case, let's just do a quick test. I'll do a V-Ray material that will make, you know, let's make one red. And I'll make another one that's blue. I'll make one of my V-Ray blend material. And then I'll drop this other one in. So if I just were to use this as it is, you'll see that it's taken red and blue, it's blended them at 50%, and I would get purple. But what I want to do is I want to take a checkerboard and mix it. And in this case, I'll apply that. I'll look at my checkerboard, and let's go ahead and render. Let's turn that off. Go to RGB. So no mystery there. Wherever it's make sure I get this correct. So wherever it's black, it shows up as red, and wherever it's white, it shows up as blue. And of course, you can dial in any type of different blend amount or blend map that you want. For instance, if you were just you wanted to create something that had these sort of speckles to it, any black and white mask will work. And you can continue to create additional layers in here. And that will start to yield kind of different results. But what you're noticing is that actually we can create sort of a faint line there if we wanted to. We can put a whole stack of materials in this setting and have a whole multi-material element created from it. One question that that I often get is, well, if you're going to create this sort of varnish on it, why not use the shellac mode? And what you'll notice is that this goes right in line with some of our physical conversations that we've been having. Basically, using this is an additive material on top of it, and it ends up breaking the conservation of energy law. So you can get more energy, sort of bouncing off a material than is naturally possible. Okay. What I want to do now is, well, let's do this. Let's take about a 10-minute break and come back at 2:40, and we'll keep going on our material mission here. Okay, so we're coming back from break here and just doing a quick sound check. Excellent, getting the thumbs up. So what we want to do, we've got a whole bunch of shaders that we want to create. One thing that I'd like to do is I'd like to start getting into a little further into taking a bunch of different maps and getting them into one particular shader. So we started to look at putting in a bump map. What I'd like to do is maybe take some additional textures and begin to control how the output of our image is going to look. And so I was thinking about maybe just getting into some brick here. I'm going to find some tileable stone or brick. I've also got another set of materials here. Let's see where I've got. And I'm just using some materials that that are from a library. In this case, they're from ProViz, and you can pick those up at the CG Architect shop. Nice for when you need to drop in some pre-made textures. Here in Boston, we deal in there's quite a bit of brick in terms of what you see on the buildings. Let me grab this one here. Okay, so we've got our brick texture. One of the first things that I'm just going to check is that it's tileable. And I'm going to go to Filter, Other Offset, and I'll set this off by 1,000 pixels in both cases, and just make sure there's no seams. Okay, that looks like it's fine. I'm going to reduce the saturation in this case just a little bit because it's a bit too much. And let's check our size, 2400. One simple question that that people often ask is, setting the sizes of your textures, and in this case, we can count the physical bricks across. So in this case, it's 32 bricks across times 8 inches is you're looking at about 20 feet. And of course, you can always calculate it exactly if you want to. We got 32 bricks times 8 inches per brick, 256 inches divided by 12. You're looking at 21.3 feet. Actually, the 8-inch includes the mortar. So the other rule is that usually 3 bricks stacked is equal to a foot. Or is it 8 inches? Now I'm forgetting my rules of thumb. But so I'm going to save this into our materials. Okay. And there are a lot of different ways to go about taking a material, a texture, and creating its component parts. For instance, if we just make a grayscale version of this texture right here, and we were to try to do something with this, for instance, we said, well, this grayscale, let's make it a bump, because a bump is grayscale. Well, what we need to realize is that, remember that everywhere it's dark, it's going to recess, and everywhere it's light, it's going to come out. And so immediately we're recognizing that we have the wrong solution for that. And even if we inverted it, even if we said, okay, all those dark areas are recessed, but all of these light areas come out, well, we're going to get a few bricks here that have some slight strangeness that's happening to it. So these bricks, for instance, would come out further than these bricks next to it, and so on and so forth. So in many cases, it requires some love in Photoshop and getting in there and painting what you need to have happen. In some cases, you can get away with, in this case, if I up my levels and we see what we're working with, well, maybe I could drop my curves down so that it's not as apparent, so that it basically only bumps out a little bit, but we still have some of those same issues. If one of the tricks that we can do is we can try to do a filter, and in this case I'm going to convert this to a smart object. And the reason I'm doing that is because in Photoshop, a smart object, we can use smart filters. And one of those filters is a high-pass filter. And depending on what our settings are here for the high-pass, we can begin to level the playing field in our black and white values. So for brick, let's say I do something like this, and I choose a low radius. You see, the higher the radius, the sort of more that comes into play. Well, now my difference between my values, that all got shrunken down quite a bit. And if I put a curves again on this layer, well, that's looking a lot better than where we started, because we've got some uniformity now. We've got, this is going to be dark and recessed. The brick is going to kind of punch out a little bit. It will have these strange little ridges, you'll notice, because of these white pixels there. But part of that can be mitigated by not having my white values come out so far and my black values come out too far either. And so we can be pretty subtle that way. So a high pass can be a nice trick to utilize when it comes to making your textures do what you want it to do. In this case, I'll save this out. And I'll call it bump. And we'll say OK. Okay, so that's one thing. In our CG School Photoshop class, we actually got in there and we painted out some tileable textures, and we went through that. It can be a time-consuming process depending on how well you want to make your textures. And we were talking here in studio a little earlier about you know, the fact that material samples tend to be pretty small, and when you every time you have a small sample trying to make that thing, you know, stretch over 20 feet, when you have a 6-inch sample, becomes a bit of a chore. Well, inside of Photoshop, what we can do is remember that we can measure our colors in here, and we've been doing a lot with our files and sort of measuring them. Well, you notice that, whoops, as I move my cursor around, you can see what those grayscale values are going to be. When we're thinking about creating bump maps, of course, it was pretty straightforward. The darker it is, it's recessed, the lighter it is, it comes out. Well, in our specular maps or our glossiness maps or our reflection maps, the same rules apply. It's just controlling different parameters. So, for instance, our brick would not have a whole lot of reflectivity unless it was, you know, a pretty polished brick. It would have a low percentage of, you know, of that. So if I push this down even further and I started to measure my colors again, and I actually like to use the 32-bit control here just because I can see these in percentages. Well, what this is telling me is that where my grout is, I've got very little reflectivity, and where my brick is, I'm talking about 10 or 15%, something very subtle and slight. And that can be nice. Now, if I push this further out, well, wherever the grout is, it's going to be less reflective. Wherever the brick is, it's going to be more reflective. And now we're talking about getting into the 50% reflection. And so we're able to kind of, you know, in our minds, rectify how much we want to have in there. Now, there are things, of course, that you can do with your file and your color correction when you bring it into Max, or you can tell it the amount. For instance, if we said this is 50% reflection in the map, but we only wanted 5, well, maybe we only use it at 10%. And in this case, what I'm going to do is I'm going to keep that very slight, and I'm even going to push it a little further so that my grout has very little or none. And we'll try to use this as a reflection map. Okay, so I'm going to get out of Photoshop. Well, I'll just minimize it here for a second. And I'm going to open up a program that is kind of a neat little tool. It's called Crazy Bump. And it's actually worth here just opening the software from scratch, because we'll enjoy the message. Oh, it used to say puny humans are instructed to wait. I guess that's no longer part of it. But anyway, what you can do is Crazy Bump does a good job at taking some of these textures and trying to interpret them into what we want to do in 3D, and it does it by a few different algorithms it has, including something that resembles what we looked at with high pass. And we're going to open up our original brick. So here's the brick file itself. Oh, there we go. Puny humans are instructed to wait. And the first thing it's going to do is it's going to give you this selection. And basically you can see that it's saying, do you want stuff to poke out or do you want it to poke in? Those are our two different options in this case. And our brick example, let's have it poke out a little bit. Well, what's awesome about this is it's a pretty good normal map creator. And it gives us a little bit of real-time feedback over here on, in this case, it's a preview ball. So I can zoom in, and you can see that there's some issues, right? Our brick is kind of wavy where we wouldn't sort of expect it to be wavy. We can move the light around by dragging our right mouse. And you'll notice that you see there's some specularity being hit on it. Well, not only does it create normals, but we can do normals, displacement, occlusion, specularity, and diffuse. So we can do all of these things right from within this piece. We can also change the type of mesh. So if I want to look at the brick wall, in this case it probably makes sense to look at the brick wall. There it is. And now what we can do is we can get into our adjustments. Slide this down just a tiny bit. And essentially we've got simple sliders and controllers. And the first thing I'm going to do is I'm just going to drop them all to 0 for you. Okay. So with all of these at 0, it gives me this normal map. And that normal map's actually kind of cool. So you see how, as I drag my light across it, it's getting all of these little fine bits and pieces that are ins and outs on the texture of that surface. And it's just reading that. It's also looking a little bit similar to what we had done with our high pass as well. I'm going to switch this back to ball. And so what we can do now is we can start to identify what these parameters are going to do. Well, intensity there is that pushed my grout outwards, and we didn't want to have that happen. Sharpen is going to bring back our details in the surface and try to pull those pieces out. Noise removal is, you can see that it's kind of smoothed out the overall image. It's taken a bit of that noise back. Shape recognition tries to identify this sort of shape in the image. In this case, that's not what we're needing. And then you can pull out fine details. So you can tweak this until you come up with a solution that you like. In our case, we sort of took out too much detail. Okay, so that's one piece of the puzzle. We're taking that brick and we're having it create this normal map. Cool. Next thing that we're going to do is let's look at displacement. And so displacement, is trying to give us a best guess with the black and white materials on this thing. And let me make sure. So we can turn on all these different options. Specularity is good to have on so that we can look at it. Displacement is pushing out some of these bricks. And if that's too much, if that's too deep, we can reduce the amount of depth that it has, or we can increase the amount of depth if it's not enough. And you see once it's 0, it's basically none. But let's create a displacement map that's really has some subtle changes to it. And okay, so now we've got a displacement map. Let's look at occlusion. So you can see that ambient occlusion now is giving us a map where it's trying to put some dirt around those individual areas. And of course we have the power. The more we drop the power down, the more subtle it is. We can jump into enhance some detail. So now we can actually put in a little bit of that occlusion. I'm going to go ahead and pull it down some, get some dirt going. And if it's too dark, we can lighten it all up. Next one is specularity. Specularity, we can adjust sort of our control here of how glossy this is. So if we want to see how much that affects our material. Not very glossy. And then in this case, the specularity maybe doesn't have so many differences, but if you ever notice, you look at a brick wall and there are certain ones that have a little extra shine compared to the other ones. There's a lot of differentiation between the ones in a wall. So this might be nice to have very slight changes in the specularity of the brick. We can control how much the texture influences it. In this case, that's not where we want to go. The brightness will determine how much or little that affects. So if we don't want it to be very specular at all, something like this brightness is maybe about right. And of course, once we bring it into Photoshop too, we can tweak it. And if we wanted to break that up just with a level of noise, we could overlay that with noise. And remember what we said about our metals at the very beginning, taking on a bit of the diffuse color and its like reflectivity and specularity. Well, here what it's doing is it's bringing on that metallic color. This one we want to have at 0. And then we've got a diffuse texture that it can go in, remove shading. It can try to remove some of the highlights that are in there. It can begin to maybe accentuate some of the crevices, highlights, or dark. And then color correction, it's going to try to adjust the sort of tone and contrast of the image as well. Great. So what we're going to do is, now that we have set up all of our pieces, I'll go ahead and hit save, and I'll do save all textures, and it's going to ask me where I want to save them. I'll say save it into my materials, and I'm going to choose a JPEG, and I'll save it. So now what we got is we've got our new orange brick diffuse. Displacement, specularity, we got all of this stuff. I'm just going to open it up so we can look at those maps. Okay, so remember we said that we can measure our values, and in this case our specular, where it's really dark, that's not giving us a whole lot of specularity, and then this is, and we can use this to control the reflectivity of the amounts. Probably by the time that we actually apply it to our scene, you know, it might even be as subtle as this. It doesn't need to have a whole lot of additional specularity. Our occlusion is going to be pretty good as it is if we choose to put this on. It's not totally necessary. Our normals here, we're going to use a V-Ray normals and look at what that can do instead of displacement. We've got displacement here if we want to try to use maybe a little displacement to push it around, or even if this became a bump map. We wouldn't necessarily need to use it in this case because we're going to have the normal map do a lot of the heavy lifting. And then here's our diffuse color texture. So let's close out Photoshop. Let's close out a crazy bump. Close out a bridge. Save our base file here quickly. And let's jump into V-Ray material. Call this brick. Go into bitmap. Grab our orange brick. Turn on that texture so we can see how that texture is applied on this. Before we do anything else, I just want to render a version of it. Kind of have our baseline with no textures added to it. That's looking pretty cool. I may just, for the purposes of our image here, reduce the tiling or make it a larger tile essentially. That way the bricks are just a little bit bigger for our demonstration instead of getting in there small. Okay, so the first thing that we're going to do is we're going to come into our reflection amount. And we're going to drop a bitmap in here. Actually, what I'm going to do is I'm just going to copy this in here so it'll keep the tile value. And we'll grab our brick diffuse specular. So this is going to put on the reflectivity. So wherever these values are, wherever these values are light, it'll pick up some reflection. Wherever they're dark, it won't have any reflection. So even before I put a Fresnel on it, let's go ahead and render this. Let's remove a couple of those from our file. That actually already looks pretty good at those values. What we can do now is if I go to my raw reflection, check that out. So this is something that's really important. One of the reasons that I wanted spending all this time with you guys on these parts of the shaders is that here's where we can evaluate what's going on. Well, when you control your shaders with a map, now you can see that our raw reflection pass, wherever it's black, it's black. It doesn't show up anymore. So as before it was 100% reflective everywhere, now we're controlling with the map where we can be more subtle with how that's working. And let's look at the reflection filter. Well, that reflection filter, what that's seeing is exactly what we were applying to our image. Now it has, of course, it has the inverse gamma shift on it, but now it's you recognize that it's a 1-to-1 ratio as to what's actually going on in the scene. If, for instance, we said that you know, this is pretty good, but I wish it was a little bit brighter, well, we could very easily just open it up in Photoshop and adjust it there. And that's what I would suggest. I would recommend just quickly, you know, kind of going into Photoshop and resaving it out. But you can also put a color correction and keep it as a submaterial. And then if I wanted to, we could increase the brightness of the material a bit. Or if I go into advanced, we can actually do a bit of a gain on it. And what that's doing is, you see, when it's got a gain on it, it makes the black points also lift up. So maybe that's not what we want. Maybe we just want a gamma. And that keeps the black points black, but it lifts up the midpoints and the rest of the tone. So you want to be careful about what you do there. Let's take a look at what the difference is. I actually think we were pretty darn close on the first stab at it, but just for the sake of looking at it with the color correction. So my estimation, this looks, you know, it's going to look a little too reflective. Some of the sidewalk bricks and things that you see have a bit more of a smooth quality to them, where you might get that type of reflections on the side. But I think we were okay where we were. Make sure we're back to normal. Great. Okay, so we've got a reflection map in there. Now, one of the things that we could do is we could make it have a bit more glossiness in certain areas. And remember that glossiness values don't need to move that drastically. A glossiness of 0.9 even is still pretty blurry. And I'm just dropping these down so that you can start to see what's happening as it spreads across these elements. Now, the reflectivity amount is already controlling where it's reflective. So wherever that's black, it's not going to have any glossy reflections. In this case, we might not need a map that determines our glossiness of this thing. We could probably get away with without a map. But if we were going to use a texture map to control this, then what I would suggest is just remember that if we were to create that map, wherever it's really low values, it's going to have a very low or almost no glossiness. It's going to be very spread out. The more of those really dark areas that you have, the more it's going to have to work hard at creating your glossy reflections. In this case, I don't think we'll need it. Let's try 0.8. The lower your glossiness values, the higher your, generally the higher your subdivisions need to go. As well as you have to be making sure that your noise thresholds and anti-aliasing are working for you. So you can see that wherever it does kind of reflect a little bit, it picks up some glossiness. In all honesty, I try not to use it unless I have to, because as we all know, it takes a little bit of additional render resources to do it. And if I don't have to make it happen, I'll try to get away without it. Okay, so notice that we didn't really do anything with our Fresnel on our reflection. We could tell it to not be very reflective at all as we were looking at it, in which case what you might want to do is in your reflection turn this into a fall off. So if I change this to a fall off and I keep that as the old map and I copy this into the new one, now basically what it's telling me is that on the front where I'm looking at it, it will not be reflective. Actually, if I turn that off, if I turn off my texture map, that'll tell me that in the front it's not going to have any reflection, and on glancing angles it will have some. If I wanted to maybe shift this down so that it was 20%, we could, and that's a perpendicular parallel, or I could do it as a Fresnel. But let's try perpendicular parallel, and that'll be a slight adjustment to that material. We don't need any refraction. So the last real piece of this is we want to get into our bump map, and we want to put in a V-Ray normal map. And we'll grab our normal map. And that will be this guy right here. Make sure that our tiling is set to work. It should be the same map channel as everything else. And for now, let's try this value of 30. Sometimes we gotta crank it up. That's a good point. There was when you load your normal map here, essentially what you want is and this goes for bump maps too, you want to keep them, I believe, at an override of the gamma of 1. We should test that. In this case, I'm not sure if that's going to work or not, but we'll test it both ways and find out if that's what we want. So we'll leave it at the gamma corrected version of it to start, and then if that doesn't work, we'll switch it over to 1. So I'm just going into my bump normals channel, and we can see what's happening there with our bump. So that's what it looks like there. Let's turn this up a bit more. Another thing I want to do is I don't want that to blur. But you notice that the normal bump is quite a bit faster than trying to calculate all that displacement and everything. And it still does a pretty darn good job of creating the light and shadows in the nooks and crannies. So that's a little bit better. There are some artifacts in here. If I go to bump normals, we could see how that's pushing the surface around. And to test our scenario of whether or not this should be brought in with without the inverse gamma lookup, let's render it this way with an override of 1 and check it out. Well, we'll save it. And we'll make that A, this one B. I'd say it does look better. It definitely looks better down here and on that. So I think that's a good call. We can do a little bit more research on that one, but I think that's correct. That it certainly looks better now that we've got that gamma correction off of the normal bump. And when we look into the bump normal channel and we compare it, it looks correct too, because this yellow color is not really a natural one for the normal bump. We should be seeing these sort of red, blues, and greens. Great. And so now what we've done is we've created a more complicated shader just by using all of those methods that we were talking about earlier in regards to controlling mathematically what the values should be and how that works. And the more definition that you can apply to your shaders and the more sort of change, the better. Yeah, somebody online mentioned that normal bumps are data, and data shouldn't be gamma corrected, and I agree with that. So it's containing explicitly X, Y, and Z values of of those datas, and so it shouldn't get shifted. Excellent. Okay, so let's save this. And the next type of material that that I wanted to look at with you guys was a glass material and start to get into some transparencies. So I'll create a V-Ray material here, and I'm going to create a very generic glass, and that is going to be a black diffuse color. There's no sort of diffuse quality to it yet. A reflection of white, so it's purely reflective, but it's controlled by the Fresnel, so it's not really true. It's not 100% reflective. And then that has an IOR of 1.55 or 1.6 or whatever you choose to do your glass. And the refraction, again, we're starting with an incredibly generic glass, is we're saying that that's completely transparent wherever it's not sort of getting reflected, and to transparency of this IOR value of 1.6. Remember to turn on your background or your checkerboard here of your glass. We don't have any glossiness in it yet, so let's apply that material and let's render it out. So now with this, with the glass material, we're gonna start seeing some of those objects beyond the bubble, and we're gonna start seeing some of these maps and so on in here, which is kind of a nice nice feature to check out. And then we're also gonna see the lens effect that's happening in this refraction. And the reason that is happening is the way that this geometry is constructed. This is essentially a solid object with a normal up here, a surface up here, and then a surface on the other side of that, that far globe. So pretty much what we would expect for a generic glass, right? Sort of passable for just dropping it into our image. What we need to do, though, is we need to make sure of a couple of things right off the bat. Inside of my glass material, you'll notice that we've got effect channels, we've got effect shadows. Well, this is showing up really dark down here, and let's turn on effect shadows. So the first thing that we're going to notice is that with effect shadows, our light's able to pass through the object, pick up the transparencies, even transmit the color, allow the light to go through. So that's an important distinction. It's also a little bit of a fake in this part, but it's a good one unless you're going to work with caustics, and we will work with caustics a little bit later. If not, it'll be one of the topics that we're going to touch on tomorrow. So that's our first distinction that we want to make. The next thing is, well, we already know what to expect in certain instances here in regards to if we change our index of refraction, it's going to change sort of the curvature of this lens and the way the light bends through it. The closer this index of refraction gets down to 1, which is essentially a vacuum. If I render this out, the more this thing renders kind of like it's not really there. So that index of refraction obviously is an important quality in terms of what we're seeing. Now, if I unlock these and I tell it to have reflection but not refraction, we're going to pick up the subtle hint of the glass actually being there because it's got that reflection value. But it's essentially like it's an infinitely thin surface. It's not bending the light at all. So just some value, some things to watch out for as you're working with glass. Let's go ahead and up this value. Let's make it 1.8. And so you're going to notice that, once that's going to bend the light even more severely, and sometimes your more sort of crystalline glass might get up into the 1.66 or 1.7 range. It takes on a bit of a slightly different IOR, but for most cases, you can keep it in that 1.5, 1.6 range. Okay, so the next piece of the puzzle that we want to talk about is our fog here. And the fog, if I make this a color, let's say I make this, let's even make it sort of a green. A green glass. Well, the fog color is pretty saturated, and the multiplier's at 1 and the bias is at 0. And notice what it's done to my shader here. It's made this look really dark. Let's give that a shot. So what we've done here is we've essentially given ourselves this sort of thick green glass effect that's happening. It's taken on a coloration of the glass. Now, in most cases, the fog multiplier and the color, I probably don't use it as something that's so severe as this, but this is perfect for demonstration purposes. Now, notice that we can adjust this fog bias here. Well, if you look at my parameter of my glass, as the higher this fog bias goes, the less intensity, the longer the distance it will travel in. And so that's giving us it's actually, in this case, it's a bit of a nicer effect by allowing that that fog to travel further. And we're going to crank it up in a second. One of the things that I want you to see is what you would expect happening here. We're looking at the raw refraction channel, and essentially we're seeing that, okay, well, we adjusted the fog color. That's making our refraction of that whole object is really picking up green. We're not changing the refraction color here. We're changing the fog. and that's important as well. And if I go to my raw reflection still has my sky color contributing to it, with of course the reflections of the object itself are giving that green. And if I look at the filters, the refraction filter, well, this is what we thought it would be. If I measure that color, we're almost white, which means it's almost it's very, very close to transparent. And because of the Fresnel fall off, it's slightly getting darker around some of those areas, making it less transparent. Now, I would say that this is probably too transparent. Remember, we started this with just creating kind of a generic glass, but glass is not generally in this sort of 95% transparent zone. It's it picks up a little bit more opacity than that. Look at our reflection filter. Well, that looks exactly the way we would think it would. It's giving us the Fresnel fall-off values. We go back to our RGB color. Let's make the fog bias 50 and render it out. In this case, I'm going to go to my history and set it. I might be running out of space. Okay, and we'll save this to our frame buffer history panel. We'll set that to A. We'll set this one to B. Pretty slight differences. Of what's happening there, right? So we're talking about adjusting that bias becomes a fairly slight rendition. If I take my saturation down and my value down somewhat, I still have my multiplier at 1. Let's render that. Well, taking that value down and leaving the multiplier at 1 has given us this really dark glass. And so now we're kind of creating this very tinted feel to it. Of course, my bias is also set pretty high. Let's go back to, I believe it's 0 is the starting point of that. And what you'll notice is that with the bias back to 0, we didn't even see through this little chunk anymore, that little piece of the glass. And that's because it's a very thick piece of glass right there. I'm going to do one more thing before we move on from that, but the fog value of your glass is one of the things that has the most impact on it. It's not your diffuse color, it's not your reflection color, your refraction color. Those things can have an impact on it, but the fog color is sort of crucial. I'll save this one. And I'm going to grab my object, and you'll see that I've got the shell modifier. I'm going to turn on that shell modifier, and I'm going to render. And what you're noticing now with the shell modifier is it looks a lot more transparent than it did before. We'll compare these in just a second. So let's save that. Set it as A, set this as B. There we go. And look at the change in the refraction. Look down here how much less it bends. So this is showing you that it's really important how you make your glass. If you want it to be a fully thick object that has all of this density to it, that's fine if that's what you're after. But if you're looking at something that you want to have sort of glass windows or whatever, it's important to have those facets, those faces of your glass be there, because the way the light bends in also bends back out. And in this case, it's going through 4 sets of faces. It's going in and out and through the back side. Another thing that's important too in a glass object that has a lot of different ins and outs like this, you'll see that we've got a lot of bubbles and those pieces. We should be really careful about the maximum depth. I'm going to turn this way up in both cases to make sure that I'm have enough trace depth to go through all of the faces, because I essentially doubled all of the faces everywhere in this by putting the shell modifier on it. So I'm going to save this to the buffer and render again. Now, by turning up our trace depth, we can be introducing some additional render time, right, because of the amount of sort of ins and outs it's got to calculate. But I found that V-Ray does a very good job. It's very fast at going through these items. As a matter of fact, one of the first reasons when I started working with V-Ray when it first came out that I was so impressed and excited about it was that at that point in time, rendering out ray traced items was so time consuming to be able to calculate, and it just absolutely was lightning fast when it came to ray tracing, and it's only gotten better. There was a question online just to make sure what was the last modification, and all I had done in this modification was to go through the material and adjust the amount of trace depth bounces. So I changed my max depth from 5 to 20 in this case to make sure that I was getting enough bounces to go through. We'll do set A, set B. So there we go. It did affect this image. Now it's subtle, but you'll see that we had missed this whole section cutting through this glass because we didn't have enough trace depths. So where we should be seeing that hole through there, we weren't. Now, did I need to turn it up to 20 to get that? Probably not, but that is important. Okay, so with our glass, we can also make this, we can start to turn this into sort of a frosted glass as well if we wanted it to get sort of blurry refractions as though the light kind of blurs going through it. And in this case, I'm going to set this glossiness to 0.9 to start, and I'm going to change my subdivisions to 16. Now, my guess is that this is going to take a couple of minutes to render. But if anybody has any questions during the interim, I'm also going to save this so that we've got it. And let's go ahead and hit render. So as we suspected, this glass is going to take a bit longer to render, and hopefully we'll start seeing some patches of this come out nicely. I think for some of the things that I want to do coming up, where we work with maybe some caustics and maybe some subsurface scattering, I'm going to switch my render size to something a little bit smaller. But let's let this one play out a little bit. Part of the reason that this is taking longer than usual is that we have this 20 bounces on our depth, or 20 trace depth. So we're getting this really nice quality. That's actually very, very nice on the side here, where you get sort of a blurriness to the glass. And of course, the lower the glossy number, if you made it 0.8 or 0.7, the more it's going to spread those points out and blur it, and the more this thing will look like it's a fully diffuse element. So there's a question about, in a physically based render, do we need to use effect shadow in the material? Well, in a physically based render, what you're actually going to do is you're going to use caustics. And once you turn on caustics, then that effect shadow is not important anymore. But if you're not going to use caustics, then the effect shadow is kind of the best quick cheat that you can use. We will set off a rendering here with some caustic shortly and hope that it renders quickly. Now, in a normal scene, you probably don't have all of this glossy refraction stuff this close up and so severe. So this is a pretty heavy duty example of it, but it happens to be, I think, a nice example of it. Yeah, so one of the questions here in Boston was, would you save some render time if you reduced your trace depth instead of 20 if we went back to 5, or even if we were going to, if this was a flat piece of glass, we might even make that trace step like 3 so that we're not making it calculate anything extra. Question online here is, in practice, do you need to test your materials in your scene or a separate environment? It's a good question. The thing about creating a physically based material is that if you make a good glass, a good stainless steel, a good piece of wood, those are going to look correct depending on, in the light that you put them in. They should look, you should be pretty darn close when you put it into your scene. But there are certain nuances and certain things that you want to tweak in your scene specifically, like the number of bounces, the ray depths, and there's also, there's certain lighting changes and scenarios where you might be getting sort of hot reflections or things that you need to compensate for. But generally, if you go through a process like this, where, and I'll do this on many occasions, where if I go through a scenario like this, I'll save out a material library of all these pieces, and you can use them, basically in any project. One of the things that we haven't done yet with our base scene is we haven't kind of given it any different aspects or qualities to it, and we're going to do that in a really simple way. We're going to measure some lighting parameters, and we're going to use some HDR files in the dome, and we'll drop these into sort of little pseudo environments around our material ball, and we'll be able to look at these in different scenarios. One of the types of materials that's going to make a big difference depending on the scene is when you start to introduce caustics and subsurface scattering. Those are all dependent on where the light is hitting it and where it's all coming from. So in those cases, you may find that you can set up a material only so far in a scene like this. And it looks like we're getting pretty close to the end on this particular render. Once we do, I'll shrink down our render size, and we won't have to go into sort of glossy refractions any further than this. There is a nice trick using the V-Ray two-sided material for fake frosted, sort of fake frosted glass. The only caveat is that you need to have just one single side to it, one single face. And if we have time either today or tomorrow, I'll pull in V-Ray two-sided material and we can look at how you can fake frosted glass with it. It's much faster. Well, let's do this, guys. Let's take a short break here. Come back in 10 minutes, right after 4 o'clock, maybe 4:05, and hopefully this scene will have rendered by then, and then we'll kind of switch gears and we'll start looking at some caustics and some subsurface shading. Okay, so we're about to come back here from break. We just want to double check that we got sound. Good, it looks like we're good. So I started to take a peek through some texture maps here to see if we can come up with a couple of things that we can test with our subsurface scattering. And what I was hoping to do here is maybe take one of these marble textures and get it to do what we want it to do. But let's take a look. Actually, this is a good example of what I was talking about before in regards to the white balance of your textures. Resize these to fit. Now, we're looking at a few different samples here of marble, and that's fine that they're different colors. They should be different colors. But what you're going to notice is that the white balance of them is completely different. If I zoom into this image and I look at, if I just use my info window here and I start to drag my cursor over this white number, you see that it's quite a bit bluer. It actually almost looks a bit purple in its balance. And it actually should, I just did a Control-Shift-B on it to fix the colors in this case, and it should look a bit more like that as the sample. You'll also notice that this white balance is very blue. You can see that the blue channel is almost 100%, where the other two aren't. So that marble is supposed to look like this. And that one's not quite going to just work with a Control-Shift-B either as that. But we want to look at our white balance if we're going to try to use these things together. I sort of like this one here. I could see this maybe having a bit of subsurface to it, so let's save it out. Now we're going to, I'm pretty sure that this isn't going to tile, but for the purposes of what we're doing, I don't think we'll have to worry so much about the tiling of it. We can get over that fact. So toss us in materials, and we'll call it marble. Great. So V-Ray has a pretty exciting set of features in its subsurface scattering, and it's amazing how fast it is. It's actually really exciting how fast it is. What we're going to be looking at here for class is we're going to go into the new V-Ray Fast SSS2 shader. And just to remind you, the original Fast SSS shader, of course, subsurface scattering here, this one right out of the box was sort of meant to do skin. So if I don't even make any adjustments to it and I apply it right to my object. Now, I should tell you that I turned off my shell modifier in this case because I want this thing to seem like it's a big, thick object. So I didn't want to have my shell geometry there. But if we just turned on the original Fast SSS and I hit render, the concept behind it was to come up with a material sort of right out of the box that could start to emulate what happens with skin and sort of skin tones. And it's nice just to take a quick peek at how the material begins to look like it's absorbing light and scattering it around inside of the object, which gives it the sort of feeling that it's got some translucency to it. Well, as we've been doing since we started class, we want to look at what that means. Well, interestingly enough, as we drag our cursor around here in my diffuse color, well, that diffuse color is solid. That's just one single color that's happening. And if we get into my raw GI, well, the GI is giving me the sky color. It's also, you can see that it's bouncing off some of those tones into my scene, so that's giving me this additional bounce. If I go to my raw lighting, well, that looks just like we normally would think. It's basically the sunlight. And if I go to my raw reflection, well, there's no reflection on it. And if I go to my raw refraction, I have nothing in my raw refraction. Self-illumination, specular. Well, where is this information coming from to take a look at it? And I believe in the render elements, there is a new element, the SSS2, that we can include. But I don't know that we're going to get the SSS2 element to pick up our original one. So when I close this down, we'll render it out just to double check. Just very quickly going through this, it's working sort of like an irradiance map would, where it's interpolating kind of the scattering of this, and we can tell it how many samples it has and where the levels change. So if we had a shallow radius that was 5 inches, well, this object is 12 inches, so the shallow radius is going in pretty deep to it. So if I make this, if I make the shallow radius go in 1 inch, and I'm going to change it to a very different color in this case, so that we can just identify it. And then I've got a deep radius in here that I'm going to go in, let's say we'll call it 4 inches. And I'll make that one green. And then we've got a back color here, and I'll just leave that back color as what it is. Of course, you can apply different texture maps in those zones. But let's go ahead and hit render. So what you're going to notice is that we put these materials on there, and we adjusted the colors of them. But the deep color, this deep color is really the one that's affecting it, because we didn't really let our shallow sort of dig down in there too far. Let's make our shallow be 4 and our deep be 10. And let's try it now. Oh, we wanted to check to see if the SSS2. So I think only the SSS2 element is only going to work with the actual SSS2 material. So we're not seeing much change in this one at all, a little bit down in here. But even this original fast subsurface scattering shader was pretty fast. This is rendering, for what it's doing, is rendering very quickly for us. So similar, we've got parameters here that we can change. It looks like maybe our shallow radius wasn't quite giving us the depth that we wanted. Whoops. Maybe give that a bit of a lighter tone. There we go. So you can do some really nice things here with this texture map to give things, or to give your materials a feeling like they have some, that they're solid. In this case, it starts to look a bit like wax, maybe. It's picking up a little bit of that purplish hue in some of those spots. Okay, well, what I want to do actually is I want to focus on the fast SSS2 shader. And one of the cool things about this is that it comes with some presets. So where if we wanted to do our skin preset in this case, if we turn it on, I'm going to go to the default here. The default is the scattering is simple. I'll delete that. So just by default, you can see that we've got an IOR of 1.3, a prepass rate of -1. We've got our colors that are the sort of overall, the diffuse, the subsurface color, and the scatter color. And then there's a scatter radius. Now the scatter radius in this case is always in centimeters, regardless of what unit you're in. So you want to make sure that you're measuring things in centimeters. And then we can add a specular layer if we want, and so on. But just out of the box, let me put on this skin shader and hit render. So that's actually pretty nice. You could see this bit of specularity that's hitting it here. It's giving us this nice change in tone below, and that was using simple, and we rendered that out in 17 seconds. So very, very fast. Now if I go to my SSS2, we can see what's actually happening here as well. So that's pretty cool to be able to look at. All right, well let's make some adjustments here. The first thing that I'm going to do is I'm going to adjust this value, my scatter radius, which is determine how deep the light sort of penetrates into my object. The deeper it penetrates, the more translucent it's going to look and less sort of solid. So if I go in, say, 20 centimeters in this object, that means it's going to be going in pretty deep. And now you'll notice that, look how the light and that color bounces around inside of that object. It looks really, really cool. Very much like a nice, solid, waxy surface. And so that, now if I look at my SSS2, look how nice and deep that goes in. Pretty cool. So one of the things with the SSS2 modifier, the shader here, is there's a lot to go through, and I actually just pulled up the help on the spot3d.com, and there's a really nice set of instructions basically on how you can go through this. It talks a bit about the pre-pass rate here, which like we mentioned before is very similar to the irradiance map when it does GI. It's essentially kind of an interpolated version of it. At -1, it's half the resolution. For high-quality renders, we set it to 0 or higher, and especially in animations, and that's one of the things that I wanted to tell you about, is that for animations, you want to turn that up. Well, let's take a look. If we go back to the material, I'm going to open up my history. We'll save this in here. And let's change the pre-pass rate to 1. So you can actually see it tracing a little bit more finite elements from that. And let's save this. And we'll set this as A, and this one is B. So in this particular instance, we're not gaining a whole lot in our clarity, and we should look at the SSS2 calculation. So even the pre-pass rate at the default of -1 was doing a nice job. The diffuse amount is going to control how much of this diffuse color it takes on. So if I make my diffuse color, let's just make it something different so that we can see the effect. Well, I'm not really getting any of that diffuse amount coming through. So if I turn this up, in this case I'll make it 0.6. You can see now that our diffuse color is going to start to show through. And basically what you're noticing is that the subsurface scattering component of it has been deepened, it's been darkened, and then the diffuse filter is now come through a bit more. So in your render element, you can see exactly how these two are affecting each other. And then, of course, if we make the scatter radius much larger, in this case, the scatter radius is much bigger than even the object is. And so we're seeing kind of less of that definition in here in the different crevices of it. So the phase function kind of determines the way the light scatters in, whether it stretches it in one direction or in another one. And if it's negative, that means the light scatters backward. Or if it's positive, like skin and milk, it kind of has this forward scattering. So as the light enters in, it sort of projects forward further. And so that's what the phase function here does. And if this is all the way at 1, that means the light projects far forward, and if it's -1, it won't project as far. It'll kind of do a backward scatter. And of course we've got our specularity here and the amount of glossiness that we want to have to it. That comes around. And then this part, the scattering options is really important. We've been using simple this whole time. If we use ray traced solid, in this case if this was meant to be sort of like a solid wax or something, I'm going to change this color. We're going to get a different type of calculation that's going to happen. And you'll notice that the scattering now feels a little bit different, and it's got this this edge here where it begins to look a bit more like it's getting that that shadow. You can see what the subsurface is doing. When you get into water and the types of water and milk and some of those, we're going to use the ray trace refractive one. So let's use that. I'm going to switch to water. And at first I'll use simple. We'll just turn on water and simple and we'll hit render. And you'll notice that, well, that's not really giving us what we were hoping for there. And if we choose the next one off of simple and we go to ray trace solid and we render that out, we're essentially going to wind up with the same scenario. But when you turn on ray trace refractive, notice that even the material slot changes here. And you'll notice that we've got an IOR that we can adjust how we want. And let's render this water with refractive. And you're noticing probably immediately that the material looks a lot more realistic and much more interesting. And it's the way that it's able to use a different algorithm for this kind of refractive subsurface scattered object. And this does a nice job of making it a pretty clear water. And the shadows do a nice job of passing through as well. Be curious maybe when we start to when we turn on caustics, how well this will react to our caustics. So the setting here for the water, and I'll save this to our buffer, is that we went to the preset, this water clear, this sort of clear water, and essentially what it did is it gave us the IOR for water, so the overall color was white. The diffuse color is black. Remember, that's just like our glass. The subsurface color is black, and the subsurface scatter color was white. The scatter radius was 300. Well, let's take a look at tweaking some of these. And the phase function had sort of a forward nature. Well, let's make our scattering here murkier. Let's make it, let's call it 10 centimeters. or maybe 15 centimeters. And we'll render it out. And so we're making the scatter radius in this point go less deep into the material, so it's starting to look a bit darker. But what we've got is we've got a couple of things left to adjust. We've got a scatter color, and we've got a subsurface color, and we're going to adjust each one of those separately here. Because right now the scatter color of white, let's make this somewhat green. So as that light enters and it sort of scatters it, it's switching it to our green color. But what we haven't picked up yet is we haven't kind of picked up the murkiness of this water. And part of that is going to be, I think, adjusting the subsurface color. You'll notice that it does a nice job of the colors coming through that, the light picking up the qualities of it. And now what we need to do is we need to give this a subsurface color, because right now that subsurface color is not doing anything to our scene. So let's give that a bit of a color. We may find that that becomes too much, but let's try it. Yeah. So the subsurface color in this case, once that turns on, now we're getting probably not the desired result that we're looking for on it. So when it was black, that really wasn't affecting our scene. And if we go to the opposite end of the spectrum, we're going to get this sort of white quality to it. And so it does look like it's scattering more in here, but now because that is so bright, it's too far. So not really the most beautiful there. I think if we take the saturation up, So I'm not really getting this to look too murky, and I have a feeling that it may just be the way this refractive one works. Let's try a really low value from essentially black is off. Let's make this go up 1. Okay. There we go. Now I could probably use a bit of saturation in that color, but you'll see that very small values of that change had a big effect. And that's kind of looking more like the murky waters of, well, not quite Venice. It wouldn't be that green, but there we go. Now our distributed bucket's picked back up. So you can see around the edges where it's not terribly deep, we have this sort of nice green color, and then where it gets thick and deeper, we have this sort of gray, and it goes from kind of being clear to really kind of murky, which is a cool thing if you're working on making sort of murky water. I'm going to save my file just so that we don't lose where we're at. And then there's a couple more types of subsurface that I want to look at. And you can, walk through each one of these different ones. I actually think some of these are pretty neat just right out of the box. And let's go ahead and turn this to milk and hit render. Oh, I'm going to make sure that it's applied. It is. So there's a question online, do you recommend subsurface 2 for water? I'd give it a try. Yeah, I could see some cool uses for it. One of the nice things about the SS2 shader is, as you guys are noticing, it's really fast, and that's awesome. So now what you're seeing is this is skim milk, and you're seeing how much light that sunlight is sort of absorbing in here, and you're also being able to kind of see what is happening with our pre-pass rate a bit. So if I make our pre-pass rate go up in this case, and I'm going to take the overall color and drop it down to 230 or even 200. Phase function is still going forward. Our scatter radius is going in 2 centimeters. I'm just going to make it increased a tiny little bit to 5. And render it again. And you'll see that with those settings set at 1, we kind of cleaned up our maps there a bit, and that's looking pretty cool. So the the last thing that I want to do with materials is, at least for today, we can talk a little bit more tomorrow if we'd like, is I'm going to switch this over to marble, and I'm going to come down here to my overall color, and I'm going to choose bitmap, and I'm going to grab our marble.jpg, and we'll look at our material property here. Looks like Max got a little unhappy with me there. I'll close down Photoshop so we can save it. And so I've got my map now in my overall color. I'll drop this down some resolution-wise so that it's not so big. And the two places that we want to look at are color is we've got overall and we've got diffuse. And let me just put it in here and copy it. And if I turn it off in overall, you'll notice that it goes back to 0, and that's because our diffuse amount is set to 0. So the first technique is we're going to toss it into overall color, and we'll apply it to our object. Let's make sure that the size looks right. There we go. And let's render that out. So the question here is, what's the phase function define again? And that controls the directionality of the rays as they go in. So the phase function will kind of, if it's positive, it'll project forward into it, and the more forward, the more directionality you'll have. And if it's negative, it's sort of a back-facing phase. So a question here, why would you use subsurface scattering for marble? Does marble absorb light and scatter light? As a matter of fact, it does. And there's quite a bit of really cool materials like onyx and so on that has a subtle translucency to it. If you look down here, this actually begins to truly look like marble, like the marble that you would expect. And if I look at my SS2, that looks really nice, and that's basically by default from this. What I would do in this particular instance, And you can see that it feels like it has its absorbing light and it's giving off this sort of subtle scattered appeal. What I would do in this instance is I would leave my overall color where it is. I would change my diffuse to be the map as well. And in this case, I would maybe make it a subtle difference, maybe 0.3. My scatter radius is 1 centimeter, and so that's pretty good. This scattering inside of this looks about right. I wouldn't need it to go any further. What I think we want on this next, though, is we want trace reflections. And so we've got a bit of our glossiness in the specular amount. I don't know that we need this. I believe this might be a fake specular. Well, what we can do is we can go to our specular element. So that's what's giving off just sort of a fake specular to this. I'm going to turn that off, even though it probably created a slightly nice effect. And then I'm going to come down to wanted to see if there was a reflection change that we could do. Well, let's give this a shot. So I'm wondering, because I turned down my specular amount, if that amount actually controls our reflectivity of it. Because if I go into my specular, obviously there's nothing in there. If I go to my raw reflection, there's nothing in it as well. So let's go back up to specular amount and try it again. Little bit bright still on that. Oh, we do have an IOR here. I wonder if that's controlling the... There we go. So now we've got it. Now we've got our marble material that's both absorbing light, reflecting the environment the way that we would want it to. It's giving us this nice subsurface scattering. Really feel like it's got some solid qualities to it. Giving us a nice look and feel to that. Might be just a little bright yet in terms of the material itself. We might want to pull down just a bit of the color there, but in general, it's looking pretty good. So to get the reflection values, just as a reminder, we made sure that the specular amount was set. I had originally turned that off to turn off the fake specular, but oh, actually, I wonder if, in this case, the phase function is negative, and that's kind of giving us a scattering the light backwards somewhat. I think if that's the case, what we may find is that's part of the reason why this light is so intense where it's hitting there. Now that might be correct in this instance, so I doubt that these shouldn't have any effect, these two colors there. Let's drop the subsurface color slightly. Render this one more time. Just because it would be nice to finish this shader and know that it's going to work. Yeah, it's still pushing back a little additional light there, but I think that was slightly better. Well, excellent. So using the subsurface scattering, we've essentially solved our dilemma pretty easily. This renders very fast of being able to do marble materials that have a nice translucency to them. So I'm going to close this down and hit save. Before we head into the home stretch, let's take a quick break. We'll come back at 5 minutes after 5, and what we'll do for between now and then is we'll take our material scene here and we're going to set it up to have a few different lighting scenarios with HDR and image-based lighting. Okay, so we're going to come back here from break one last time, and we're going to round out the day. So one quick material thing that I'd like to do before we put materials to bed, essentially, is there is a new feature inside of V-Ray that if I put my glass material back on, and in this case I'm going to make my max depth 10. I won't make it quite as large. And I'm going to turn off my glossiness because making that come through there took a long time to render. Well, what we're going to do is we're going to turn on one checkbox here, and that's dispersion. And dispersion is going to give us, well, let's render it without dispersion first. Should only take a couple of minutes. And in this case, I'm actually going to turn my shell back on. Oops. And I'm going to drop my fog multiplier down to maybe 0.2 or 0.1. I don't quite need as much color as I was getting in this when we were demonstrating the fog. So just turn it down slightly. So we're getting our glass here rendered out sort of the way that we had done it before. And we've got the shell modifier on it so that we get these nice crystal clear looking pieces. Next, what we're going to do is we're going to turn on dispersion to it. And you notice that dispersion has one parameter. And again, we'll do jump into Wikipedia here. ABBA, not to be confused with the band. So the ABBA number here is affects the transparency of the material and its dispersion, and there's all of this fun stuff that you can pick. There should be an ABBA number. Let's see, where can I find there should be a list of ABBA numbers. Well, you can see that ABBA numbers are used to classify glass and other transparent materials. Flint glass is less than 50, crown glass is a little greater than 50, and 30 for polycarbonate plastics, 65 for crown glass. Really deep crown glass is 85. So what the 50 value is giving us kind of a glass dispersion value directly in the middle, and you can read about the different physics that go along with that, as well as the Ernst Abbe, who's the German physicist that it was named after. But in our case here, we're going to leave this at 50, and we're going to give this a render. Let me save this into the buffer. And you'll notice one thing, that first and foremost with dispersion on, our glass as it's going through its rendering phase here looks like a multicolored rainbow of interesting stuff. But as it goes to render this, it will clear up in areas where the refraction will pick up some of this dispersion. And in this particular case, we might not see it too well in the thin glass. We might need to make our glass be more of a solid in order to pick up the dispersion. But we'll give this a try and see if we can't You'll notice that it is taking a bit longer for it to calculate and render as it's going through the motions here. Maybe we'll pick some up in this thicker portion. checking the raw refraction channel here to see if we've seen any render so far. We picked up a little right there. It's a little dispersion. You can see what's happening in the glass there. It's breaking apart the component colors. And we're picking up a little here too along this edge and along this whole path right down at the bottom, as well as right in here. You could see how it's giving us these colors. The refraction is basically of this glass is separating these colors into by their various wavelengths. So we'll let it finish just a little bit more here before we cancel. Okay, so if I cancel this and I save it to my frame buffer, or my frame buffer history, and I load this as B, I'm sorry, I want to load this as A and this is B. So on the left-hand side is our dispersion, and you can see down here at the base of this where that dispersion really comes into play. It's very apparent right here, and along this edge. And that is more closely mimicking the physics of that particular glass. In this instance, it would probably have been more noticeable if we didn't keep the shell modifier on, but it is a nice new feature to V-Ray 2.0, especially for glass transparent objects. Okay. So when we created our scene here, and go to my top view, we just use a V-Ray Sun and Sky system. And the V-Ray Sun and Sky is nice for these sort of generic tests, but we want to get in some real environments to our background. And the first thing that we're going to do is we want to take this background, since we know that it's physically accurate, and we want to be able to measure it. The other thing I'm going to do is I'm going to make a copy of my sun, and I'm going to drop it down towards the horizon, and I will disable my original sun. And now if I render this, now keep in mind I haven't adjusted my camera setting yet. I'm still at f-stop of 16 with the 1/160th. If I go back to my exposure value table, jump into here. We're going to look at what it should be for a sunset. areas in open shade, a clear sunset, a sunset and skyline just before sunset's an exposure of 12, value at sunset is 12. So let's start there. Let's say that we want an exposure value of 12. I've got f16. I connect the dots. So that's 1/15 of a second is what I want to start with. So we'll put in 15 here. And let's render this out. I am going to apply, let's apply our marble material to this. It was rendering pretty well. Let's see what the marble looks like at sunset. Not a bad guess on the exposure value of our camera, right? So we know that that philosophy is working. We can put it to the test. So right where that sunlight is hitting it, that's where we would expect that subsurface scattering to sort of push, especially with the back-facing phase of that, we would expect that to really kind of illuminate this just like it's doing. And then on the cool shadow side here, we would expect that to taper off some. And just to take a quick peek at what's happening under the hood, diffuse color, well, that stayed the same. That didn't change. The raw GI, well, that did change. We're seeing what's happening to the bounce light there. The raw lighting, of course, here's our sunlight as it's cascading across the face of our scene. The raw reflection, okay, that's that. Our raw refraction. Doesn't have anything because that's a solid object. It's not self-illuminated. And then if we look at our subsurface, well, here we can see where our subsurface is really, especially around this edge. See how that's absorbing that light through that thin part? And that's really looking nice. Great. So we have two scenarios to work with. We've got a daylight scenario and a sunset scenario. I'll turn the sunset off, and I'll turn the sunlight on. Now what I'm going to do is I'm going to put a camera in my scene. And it's just going to be a free camera here. It doesn't really matter so much. And I'm just kind of putting it in perpendicular. It's not totally necessary that it's exact. I'm just kind of pointing it up in my scene. And if I look through that camera, I'm not really seeing anything, but that's okay because I don't mind. What I'm going to do is I'm going to go to my rendering under V-Ray, and I'm going to choose camera, and I'm going to render out spherical. And with spherical, I'm going to choose an override of 360 degrees so that my camera is going to see my entire environment. Everything else can be the same in this particular case. I don't actually need the GI and all of that on because I want to look at what my environment, my sky contribution is. And I also want to go to my V-Ray frame buffer, and I want to change my width and height. In this case, I'm going to make it 2000 by 1000. Needs to be large enough that you can get at some measuring of your colors that are in there. In this case, we want to be able to measure the sunlight. And it should be a 2-to-1 ratio. The image aspect should be 2-to-1. Okay, go ahead and render this out. Okay, so nothing's showing up in my camera here, and we got to figure out why that is. Well, sunlight is on. Because I'm using a regular camera, let's try putting on the V-Ray exposure control. And let's set it up to the same parameters as our first camera, 60, 16, 100, neutral. Make sure that my environment is on. We need to process the environment. Oh, that's one of the downfalls of being inside of our frame buffer, the different ones. We weren't in the RGB color. So that explains what was going on there. Go back to our camera. Let's try this without the exposure control first. What we want to get, the whole purpose of this, and I guess I'm going to need it. Is I just want to be able to measure my background. I'm not sure why it wasn't rendering. Huh. For some reason, I think this happened to me the other day. Well, in whichever case, I'm going to use a V-Ray camera. For some reason, it looked like our other one wasn't showing it. That's fine. This will still work. There we go. So I've got this big white splotch in here. And that's because what I'm trying to do is I want to get at the uncorrected float values of my scene. So what I want here is I want this value of my sun. But I think you can do this without having that to have to go through that. If we put on the exposure, we change this back to 60, and we render it out even with the exposure on, I think it'll give us the uncorrected values as long as we choose them. So I'll turn this off. What I'm looking for is this spot right there. There it is. So what I did, I set up a camera, I looked at my V-Ray sun and sky, I dropped the exposure down so that I could get at the pixel values of my sunlight, and I'm measuring those. Those values are telling me float values of 52,000, 67,000, and I can take a sort of general average of what those values are. The reason that I'm doing that is telling me the intensity of my sun in float numbers. Well, that's great. If I take note of this thing being about 65,000, roughly 70,000, that's the float value of my sun. Well, now what I can do is I can go to an HDR file, and I'll just leave this open for a second. And I'm going to go to Bridge. And I believe I have some of these hyperfocal skies. Now, the hyperfocal skies, really nice high-resolution skies that you'll notice say VHDRI, and those are very high dynamic range. Essentially, if I just go to the thumb viewer first, we can see all the different skies that we've got as HDRs available for our scene. Well, what's nice with using an HDR is that you have clouds, you've got atmosphere, you don't necessarily have atmosphere, but you have a lot more interest, visual interest going on in your file. The one that most resembles ours here, if we go back to my frame buffer, you see where that's about midway in the sky. Well, we don't need to necessarily find an exact match, but this is pretty good here. This cloudy of 4 might not be so bad. So if I come down to cloudy of 4 and I grab I'm actually going to grab the HDR file and the EXR file. And I'm going to drag these into my materials slot. Yep. So now I grab those ones. While I'm at it, I'm going to switch gears to my other sunlight. I'm going to take this sun, disable it, this sun, and enable it. And then I'm going to change this to be 1/15. Go to my camera. I'm still rendering 2:1. And I'm going to reduce my exposure. Come down here. All right, so this is lower in the sky. It's less intense. It's roughly around an average of 30,000, 25 to 30,000. All right. So let's go back up to our magic hours, thumb viewer, images. Well, all of these are nice and low in the sky. That's a pretty good one right there. So is this one. Let's try 03. So I'm going to go into my VHDRs. I'm going to go to Sunset Cloudy 03. Grab the HDR, the EXR. These are big files, by the way. They're 100 megabytes because they're huge. Really nice quality files. I'm going to drag this into my materials. All right, now if I go to materials, just going to double check that they're in there. Excellent. So what I need to do now is I need to open up those images, those HDR files, and I need to measure what the sun values are actually giving me. In this case, I'm going to go to my materials folder. Let's grab the first one, Cloudy HDR. Not sure where my file went inside of this. Let's try a different one. Not sure why my file is, can't quite see it in here. Let's just double check that I can open those up. Maybe I will shrink these down just a little bit so that they're not quite as cumbersome to work with. Oh, I see what's happening. I can't open it in... Oh, there we go. Maybe it's because it was a read-only file. There we go. All right, so here's our file. I just zoomed out by hitting Control minus. If I hit minus on the keyboard, I can reduce the stops of that, and this is exactly what we did in Max. We just reduced the stop. If I put my cursor over this item right there, I can read my float values down here in the lower right. Well, that says 27,000, roughly 27,000 across is what we're reading. Well, in our scene, 27,000 wasn't quite enough. We were looking for something that was in the 60,000 range. So those pixels essentially need to be twice as bright as they are. Well, what I can do is go into Photoshop. I can grab that cloudy HDR, and I can take my exposure slider here for 32-bit and just slide it down so that I can see what's going on. And really all I need to do is take some of these pixels right here it keeps turning on my grid there. And if I do an image adjustment exposure and I lift this up, unfortunately there's no necessary rhyme or reason to, at least that I'm aware of what the relationship is to an adjustment and exposure to the float value. So I'll save this as B. Jump back into HDR shop. Open up B. Control minus to zoom. Minus to look at this thing. Almost there. We got about 50,000 out of that, so I bet you now you could open this up in After Effects or Shake or Nuke or something that'll read a floating point, make a mask selection, and do it that way. I just do it in Photoshop because, well, it's easy except for the fact that it doesn't read the floating numbers the way that other software does. But it's also something that people tend to everybody has. So just to make sure that you can do this, I'll go back in, open up. There we go. Now we've got our 60,000 value. This thing's ready to rock and roll. Close it down. Go back into Max. Close that down. I'm going to turn off my sunlight. I'm going to put in a sky dome. Make sure I'm putting in a dome. I'm going to go into material here. Grab a V-Ray HDR. Browse to my Cloudio 4B. Change it to spherical. And right now I'm going to leave the multipliers, the horizontal rotation, all of that stuff set up to be okay. And I want to make sure it's not invisible. And I'm going to use this camera spherically. This one's supposed to match my 60th of a second, so let's go to it. And I'm going to render that out. That does not look like it rendered my... Aha. Helps if I put the texture in it. That's what happens when it gets late in the day. There we go. Now we're in better shape. So one thing to be aware of, when you put a map inside of the dome, we measured this from the environment slot, is where we measured our values. When you put the map inside of the dome, it doesn't necessarily correlate one-to-one with that environment slot. So what we need to do is we need to do one more measurement for a multiplier. And I'm going to stop this thing way down, and I'm going to zoom in, and I'm going to right-click. And you'll see that in this case, we're at 33,000 and these bright spots. We wanted to be at 60,000. So what we need to do is we just need to adjust our multiplier of our HDR accordingly. And that's easy enough to do by coming into the HDR and changing it to 2. And now when I measure this out, we're just a little bit above where we want to be, 70,000-ish, 60, 67, 68,000. There's two places where you can do this. You can change it in your HDR multiplier, or there's also the multiplier inside of the dome light itself. And the dome light gives you this default multiplier of 30. I left it at that. We could adjust multipliers, to compensate for each other. But basically, all we really wanted to make sure was that when we go to render our image, and I'm going to go to render it now by changing this back to 480 by 600, I think is what we were rendering. And then my camera setting, I need to turn off spherical, go back to default, turn off override. Double check that my sunlight is not on. Save this as HDR scene. And now let's go ahead and render. Now, one of the things that is gonna be apparent here is that we measured it and it's coming down. It's a little too bright. Well, what we didn't take into account in our measurements is we didn't take into account the sort of sun. We only took into account the sun intensity, but we had no clouds in the sky that were giving this any additional illumination to it. So in this case, we have elements of the scene that are rendering nicely, but then there are elements that are way too blown out. So essentially, we got it close by doing our measurement, but in this particular instance, I bet you if we look at what this looks like as 1, because the clouds in the sky are going to impact that overall illumination, we can sort of tweak this a little bit. The other thing that we didn't look at yet is we didn't look at the rotation of that HDR according to where it should line up. But what we're going to get out of this scene here is we're going to get some environments that we can start to drop in as our backplate for rendering out our test materials. And one of the things that I like to point out about this technique, and we're still a little bright on our multiplier, but I've heard people say that you can't get sharp shadows with HDR images. Well, we got them. In fact, it does a really nice job of, it all depends on how large that sunlight is inside the map and how wide it spreads out. In this case, it's just because the values aren't bright enough to mimic what's actually happening in the environment correctly. And of course, this is floating point, so I can still adjust and fine-tune my final camera exposure a little bit if we were getting that thing to be a little too blown out. In this case, I'm not adjusting it too much. I was only a half stop off. So now our materials are really kind of coming to life because we've got this improved atmosphere, and you'll notice that even the subsurface still works really well with that dome light file. And there's only that one light and that one map in our scene that's lighting this. So one more test. make a copy of this dome light. I might even just take that original one and drop it to maybe 25, so we're okay. The next one, same process. We want sunset. Yep, there we go. HDR shop. All right, this value is in the range of 100, 27. That's roughly around an average of 60 or 70 in there. Well, those pixels are going to need to come up quite a bit because we measured our other sky to be, I forget what it was, in 15, 20,000 range, something like that. Pop it open. Okay, so we're still way below what we needed to do, and that was up 4 stops, so you can do 4 more on it. There we go. Now we're in the right range. All right, and that was 1/15 of a second at our sunset. Switch on the override and the spherical. Got to make sure that I'm in 2x1. Also got to make sure it's on because I copied a dome light that wasn't on. That actually hit the spot. Only problem is we need to swing it around the horizon a little bit. So let's go to our horizontal rotation and let's rotate that 90 degrees. Didn't quite make it. That's in a pretty good spot. Going to save. Remember to change our camera back from a spherical camera. And switch our size. And if all goes according to plan here, we should get our marble material at sunset.
Generally, prefer to use V-Ray dome lights for the sharper shadows rather than use the environment slot with the HDR environment slot.
So there's a question here about do you prefer to use the V-Ray dome light versus keeping the HDRs in the environment slot? And the answer to that is absolutely 100% all the time. The reason being is the dome light has a much better sampling algorithm for image-based lighting, and so its ability to sample HDR files is far superior than the environment. Even if you use the dome light and you store it with your radiance map. So a lot of times, you know, like what we're doing here is we're using the dome light and we're getting all of those soft shadows from it. But you can store it with the irradiance map and you'll sacrifice the quality of those shadows, but you won't have as much noise in it. It does a much better job than the environment does. You can create a piece of geometry in your scene like a dome and apply a V-Ray light material or put an output on a map, and that will sample pretty well as well. But the V-Ray dome does a really great job with HDRs. Okay, so this is going to bring us to the conclusion of our day one, and we worked through a lot of different types of materials and renderings and so on. Setting up some quick little dome studies here, I think, is a really great way to have a couple of different scenarios where you can look at your materials. But as you're noticing that once we set it up in one spot that looked good, as we put it in these different environments, it still is looking correct. The one thing that we didn't do in terms of an environment is we didn't take an HDR and try to put this inside of a room yet, and I think we'll do that as one of the first items of business tomorrow. We still have quite a bit of ground to cover in regards to we're going to be looking at depth of field. We're going to be looking at motion blur. and some stereoscopic things. We're also going to be bringing in our composites into After Effects. We've got some glare to do. I believe there was a question about still doing volume light and caustic. So we'll have those things to cover tomorrow as well. And if you have any questions, feel free to post them now. If you're here in Boston, let me know. Okay, well, let's reconvene tomorrow at 8 a.m. and we'll kick off a good second day.